Um, so this is just a screenshot showing that these three online tools that index all packages show different dependencies for the same package. So this is still up, and there's more details in the blog post. So deps.dev see URL lib3, while snyk and socket.dev see charge set normalizer. Okay, so I talked about manifest confusion and distribution confusion. And this is resolution confusion is an attempt at an umbrella term. And again, if you've seen this before, let me know. But it's all the ways to resolve a package into something else than you expected. So of course, we have dependency confusion, where the package is installed from the wrong repository. Manifest confusion, where there's multiple ways to resolve which dependency a package has. And then distribution confusion, where you might get the wrong distribution. So briefly on how I approached this research. So I was actually starting to implement a transparency log for PyPI. And then I had some assumptions that led to some bugs. And I started reading the PyPI source code. And it turned out that the allowed inputs were greater than what was needed to do a regular upload. So I wonder if this was possible to exploit. And then, of course, you can only have one source distribution got in the way, and I started to look for bypasses for that. So the 4 blog posts I released today is here. I've touched on most of these, but the second one on reproducibility in PyPI, that has a lot of other ways where you might get unexpected results with Python packages. And with that, I can take questions.
Anybody? Questions? Up top, on the balcony, downstairs? Yes. Excuse me.
Thank you. Now that you've seen that this possibility exists, have you had the opportunity to scan through PyPI, for example, to see if there are packages that could be vulnerable to this, do have these confusions in place, or other in the wild occurrences of this?
Yeah, so in general, because the file name rules have been so lax historically, there's a lot of garbage in the system. And for the most part, it looks like it might be accidental, but I haven't looked closely enough to know if it's accidental or not, those issues that are present. So that might be future research. But luckily, like, this is easy to scan for, right? It's easy to detect, much easier to detect than if a package is malicious.
Anybody else? Questions for Stian? Manifest confusion, distribution confusion. I like the rhymes. Where is the hand? Keep it up. Hello.
So the prerequisite that was listed, what does that mean, and how hard is it to get it?
So that basically means you need to compromise a package to be able to publish as the maintainer. So it could also be, of course, that the maintainer turns evil, but you need to have permissions to actually publish packages, which should be a high bar. And basically, when you are pulling in a project, you are trusting that project to not do malicious stuff, right? So this is just one malicious thing you can do if you have those permissions.
Anybody else? Questions for Stian about these Python package distribution attack vectors?
Hi. I was wondering, you mentioned detection. Do you have any examples of good tools or ways or mechanisms to implement to detect these scenarios?
Yeah, as far as I know, nobody except the test code I have is doing that detection.
All right. And you'll be here today, Stian, if
Yep.
anybody has anything else they want to ask you. You can also ask him about quantum cryptography,
Yep.
if you like. So thank you very much. Stian.
Thank you.
All right. So that was our last talk before lunch. So luckily the talk with the sandwich in it was well placed. Let's find our way down and grab some food. The food might not be out until 12 when the scheduled lunch was happening, but it's coming. And we'll be back after lunch for the rest of the program. Thanks, everybody. Welcome back, everybody. I hope you had a chance to grab some food and chat with some new and old friends, colleagues, acquaintances. A couple of comments before we get into the rest of the program. If you pre-ordered a T-shirt, please pick it up. There are some T-shirts that have not been claimed. If you did not get a T-shirt in your size due to our delayed shipment from our supplier, please go downstairs and talk to Panita at the Reg sponsor area and work out a solution with her. We can do refunds or we can get you your shirt when it arrives. We also have some of these shirts from last year's event, and you can pay what you want if you would like one of those shirts as a donation. Up to you. Any shirts for this year's event that are not picked up by 5, we will put them up for sale as well, because many people have asked and we're waiting for everybody who pre-ordered to get those. So just shirt stuff. Okay, it was inevitable that we would have a talk about AI. So Preben is a PhD student at NTNU, Trondheim, and he's working on ways to break AI and hopefully some solutions for how to fix it. Fingers crossed. Take it away, Preben.
Thank you. Excellent. Yes, my name is Preben. I'm at NTNU and also at Simula Research Lab here in Oslo. And I'm going to be talking about ways that you can break AI systems using something called adversarial attacks, and some ideas for some solutions that you might want to implement, which is what I'm researching in my PhD. So first, just a bit of housekeeping. I'm going to start off with a brief introduction about how neural networks learn, how they're trained. I'm going to be talking about deep neural nets, which, if anyone doesn't know, that's the sort of the main AI architecture that you'll find in ChatGPT and the algorithms on TikTok as well. So after that brief summary, I'll go through what adversarial attacks are, how they work, and why they're a problem. Hopefully convince you of that. And then in order to introduce a solution, we first need to talk a bit about how neural nets represent information. You could say how neural nets think, if you want to anthropomorphize a bit. And then I'll introduce what we call the causal neural network model, which is sort of my area of research, and end with some thoughts on the state of the art. All right, so first things first. For the purposes of this talk, I would like you to think about deep neural nets as very powerful pattern recognition machines. They're very good at finding statistical patterns in data. They could be very complicated patterns, such as, for example, the patterns relating the pixel values in an image file to the label that you would like to apply to that image if you're building an image classifier. And I'm going to be talking about images in this talk because they're quite nice and visual, but everything I say is sort of equally applicable to AIs that deal with text or speech or stock prices. Okay, so we're trying to identify patterns between some input X and some output Y. We have a very powerful machine, but because this machine is so powerful, it can spot patterns that are false, patterns that don't generalize. So I have an illustrative example here. If you imagine training an image classifier on the cows in the center there, and you train your AI to say, these are pictures of cows, then the AI will likely pick up on the fact that Okay, all of these, they have like some green grassy stuff in the background. That's probably related to what it means to be a cow. You train this, you get good accuracy, you deploy it, and in production you encounter the image on the right. And it's very likely that your AI is going to fail because that pattern no longer holds. It was a false pattern. All right. That's all well and good. It's a cute example, but it allows you to do some more malicious stuff. It allows you to do what we call adversarial attacks by sort of exploiting these false patterns. An adversarial attack for images consists of you start with the image there on the top right, which is of a panda. You have an AI system that correctly classifies that image as being of a panda. And then you add some noise to it, some carefully crafted noise, just a tiny bit, to produce the image there on the bottom right. Probably from the distance you're sitting, you can't even sort of tell that something has happened. It certainly looks quite similar. It's just a tiny bit of noise. But the AI system that you trained now fails completely to classify this as a panda. I think it's a cat in this example with very high confidence. And we think that the reason this happens is because, much like the sort of grass cow example, there are some more complicated patterns in your data as well that aren't as sort of obvious and explainable. They can be to do with sort of fine structures in your pixels, all very complicated stuff. And it means that you can add noise in just the right way to trip up the AI. So that's what an adversarial attack is. And it's obviously not that big of a deal if you're just classifying pandas. But, if this was your self-driving car, or if this was supposed to diagnose like cancer tumors or something, then it's a bit of a problem. It's very interesting to note that although AIs are very susceptible to this type of attack, humans are basically immune. Like, hopefully no one in this room looks at the bottom picture and thinks it's a cat, right? All humans sort of naturally are able to defend against these attacks. And the hypothesis is that the reason humans are very good at this is because we are naturally good at extracting what we call the causal information in this case, an image. And that means we're good at extracting basically the important information, the information that affects, in this case, the classification we're trying to make. And we're not fooled by sort of random noise in the background, the way that these statistical pattern machines are. And there is a theoretical solution to this vulnerability, and it is, if you're trying to recognize pandas, you just need to collect all images possible of a panda. You need to go out with your camera and take pictures with all types of backgrounds, all types of lighting conditions, and camera angles and lenses and all that kind of stuff. That's obviously kind of impractical. So we would like a solution that we can do without having to leave the office. So to introduce sort of why or how we can go about solving this, we first need to dig a little bit deeper into how neural nets think, how they represent the information that you give to them. So I've drawn a very simplified schematic here of a neural network, in this case processing images. This could be the panda classifier. And we see that a neural net consists of a bunch of layers, and they process the information you give it sequentially, starting with the first layer and then moving up to the second and so forth. So the first layer here looks literally at the RGB channel values of every pixel. So that's very That's a lot of information. You can have 200 by 200 pixels in an image with 3 color channels. That's 120,000, I think. But that's very low level information. That's raw pixel data. Then there happens a bunch of processing, and the information is fed to the next layer, which is smaller. So this next layer has a smaller capacity for sort of storing information, and it needs to sort of disregard the low-level details and then try and sort of extract some more high-level stuff. So the next layer might sort of learn to identify basic lines and corners maybe in your image, do some like very basic processing. And then you sort of move down the chain here to deeper and deeper layers. And at every stage, the information is compressed down to a more sort of abstract, high-level representation. So at the very end, you might have quite a small layer that encodes information about, I don't know, like faces and sort of fur and snouts or whatever for your animal classification. And then at the very end, a prediction is made based on that sort of compressed information. So you can basically think about this as a lossy compression algorithm aimed at sort of extracting a particular type of information. Okay, so this allows us to sort of reduce down from all the possible combinations of pixels to a smaller combination of sort of high-level codes or compressed representations of the same information. Right. We now have all the pieces we need to think about what we call the causal neural network architecture. And instead of having a single processing pipeline, like we saw in the previous example, the causal neural net takes in the image and then produces 2 independent sort of information streams. Label 1 C here for content, the content of the image, such as subject and shape. And there's one called S for all the other information, the lighting, the camera angle, call it the style information. So this is an architecture which aims to separate out all that important information to put it in the C stream and leave all the unimportant stuff, all the style information, all the like grass information in the S stream. And if you're able to do this sort of correctly or sufficiently accurately, then you can do something quite clever, which is that you can introduce, there's a little box here that says perturb signal. What that means is you take in your style signal and you jiggle it around. You add some noise to it. You flip a few bits here and there just to try and corrupt it a bit. Make some variations on the original style signal. So you might, produce sort of, say, 10 different variations on the actual style signal that was in the image. And then you sort of one by one recombine these with your content stream, and you have your neural net make a prediction at the end. And very crucially, you tell your neural net that regardless of what I do to the style signal, you should always predict the same label. So this sort of allows you to approximate that gathering of all possible images in a much more manageable format, and under certain quite lax mathematical conditions that I'm not going to go into, this sort of converges to a system that is able to do what humans do, to sort of extract the causal important information. So this causal neural net architecture is quite a new thing. I think the first papers I saw discussing it are from like 5-ish years ago, maybe, and they've gained a lot in popularity over the years since, because they are, as we've talked about, not fooled as easily by adversarial attacks. They're not fooled by sort of adding noise to images, or if you're doing text, they're not as easily fooled by swapping words and sentences. But we still have a long way to go, even though they have all these sort of desirable properties. And so that's what I'm doing in my PhD. I got 3 years left, so I'm sort of trying to make some progress on these things. There's a lot of interesting stuff that goes into that green box. That's a separation mechanism that tries to separate these information streams. That's highly non-trivial to design. There's also a question of how you know that the C and the S signal streams, that they contain the information that you expect them to contain. And how do you? We've talked in very qualitative terms here. How do you make this sort of mathematically rigorous? So a bunch of open questions, but they have shown a great deal of promise. They're good at adversarial attacks. They're good at generalizing, doing stuff like training on one data set, testing on another data set, those types of tasks. And I'm quite a fan of them, as you might have guessed. Otherwise, I wouldn't have spent 4 years of my life sort of researching them. But so hopefully that sort of piqued your interest in how these can be used to make more secure AI systems. Thank you.
All right, this was a short talk, but we finished early. So, anybody have any questions? All right, let's go.
Hi. I remember reading a tweet from some cool guy in neural network some time ago. I think it was Jan LeCun, but I'm not sure.
Yeah, he
And
tweets a lot.
Huh?
He tweets a
Yeah,
lot.
probably. So basically what he said is that any attempt to make your neural network smarter, but trying to explain it how to think is bound to fail. Eventually, the bigger neural network with more data will win. So it's a failing strategy. So what do you think about that? And also another question is, when you showed the first adversarial attack with some crafted noise, my first, what I thought was maybe it's about how we access this data, humans, that, for us it's a little bit blurry. We don't get access to the individual values of those pixels. So why not just make the image a little bit blurrier with some random noise? In other words, just put your perturbation step as the first step, and that's it. Why doesn't that work? Thanks.
Yeah. Okay, so to answer the first question first, which is, can't you just solve this with sort of more data? The answer is yes, eventually. If you have sort of infinite images, you're guaranteed to get a robust or a secure neural net. But I think the question is more about how quickly you can get to that step. Because if it requires it's very possible that it requires more images than humanity will ever produce in its lifetime, and then it's sort of unattainable. So I think the causal neural net architecture enforces sort of some guidelines on how you'd like the information to be processed to use that data more efficiently. Because with perturbing your style, you can basically turn one image into 10 or 100. So it allows you to sort of extend the data that you have. And I also want to say that Jan LeCun has published a full manifesto about how you should make AIs think. So, who is he to talk? To answer your second question about why don't you put the perturbation step as your first step, that's a good idea. It's an established strategy, which we call adversarial training, and it basically means you do this to your training set and then you train. The issue with that is that it sort of makes you good at defending against a specific type of attack. It makes you good at defending against the attack you trained against. But there are sort of many different attack algorithms, and you need to patch each one. And if someone uses a different one that you haven't trained on, then you're a bit screwed. So that's a practical solution for sort of patching problems, but it doesn't solve the underlying issue. So you apply it to the image, and the image is the input to the. Well, you're applying it to the pixels or to the label? Yeah. Oh, yeah. So, you mean like before you train, you blur your image and then you train so that it's not sensitive to being blurred, right? Is that? Okay. We can discuss the ins and outs of adversarial training.
Yeah, thank you very much, Preben, and he's here hopefully for the rest of the day.
Yeah.
So feel free
around.
to take up this and other discussions.
All right.
Thanks. Thank you very much.
Thank you.
All right, up next we have Swan Bouchard and Gautier Ben-Em to talk to us about something completely different. This is the fast-paced part of the day where we go back-to-back, shorter talks. All right, guys. Take it away.
How do I get that? We'll make it work. Where's the pointer? Faut le Vas-y, clique. Fais F11. Yeah. Okay. Good. All right. Hello, everyone. So today we will talk about GraphQL security, and we will dive in the report we published about the topic. We also have a few surprises at the end, so stay tuned. First, we will introduce Escape. So at Escape, we are building a fully automated security platform. So the interesting point is that we are totally agentless, and so it works only with an input domain and an authentication strategy if you want to go deeper in your application. Escape is known for its unique IP traversal algorithm. We will go deeper in the subject later. And we are actually capable of testing business logic and not simple fuzzing through reinforcement learning algorithm. With that algorithm, we will generate legitimate sequences of requests and exploit complex attack scenario and chain attacks such as SSRF and stuff. We're also known for our recent work about attack surface management. So you have a lot of input here, but attack surface management consists of referencing any endpoint exposed on your organization, just like Google search would index an application. At Escape, we do have a team dedicated to finding new vulnerabilities, 0 days, fingerprinting engines on GraphQL and REST application, and continuously improving this algorithm. So you can see the result here. All right. So let's get right into the report of GraphQL security topic. So we scan 1,600 API endpoints. Each of these endpoints were publicly accessible for legal reason, I guess. And so that represents a cumulative duration of 460 hours. So that's a lot of computing power at a lot of cost if you are on AWS. So we collected almost 47K security alerts, which is quite a lot. On average, this is 30 alerts per GraphQL endpoint. So this is really interesting if we do have some people in bug bounty here, because we will present you some specific GraphQL findings and some CV we reported. It happens that sometimes people tag us on HackerRank and HackerOne to say, okay, here is some kudo for the CV you published. I just got a bounty for that. So if you wish, you can already scan the QR code or take a picture of it if you want to access the complete report later on. But let's introduce ourselves. So here is Gauthier. He's full stack engineer at Escape, and he is also leading the web application team. And I am Swan. I am a security software engineer. I am leading the cybersecurity and R&D part. And if you are stuck in your CTF, I am also experienced in binary exploitation.
Well, thank you, Swan, for this introduction. First, let me ask you, by raising your hands, who is familiar with GraphQL? Oh, quite a lot, actually. That's great. We'll start by introducing this technology named GraphQL and explaining why it is vulnerable by design. GraphQL is a query language built around types and fields rather than endpoints. This allows front-end developers, applications, to query exactly what they need, effectively moving from the backend for front-end paradigm. Some types may expose other types through their fields, effectively creating a graph data model. It was designed and used internally by Facebook since 2012 and was made public starting 2015, and companies started to get attracted from Fortune 500 to startups. There's another reason why GraphQL is getting popular is the graph model allows creating some kind of API gateways, effectively exposing underlying APIs built with different technologies, or GraphQL, or REST, whatever, by grouping all the data the underlying exposes inside a big graph with joint concerns such as authentication. Here is a rather complicated GraphQL query, which allows me to introduce some vocabulary. A GraphQL query starts with, perfect. In the top left corner, an operation. There are two main kinds of operations, queries and mutations. We can loosely map those to queries mapped to GET requests, GET HTTP requests, and mutations to HTTP POST requests. We will detail all the other kinds of tokens in this query when we will talk about the vulnerabilities they imply. There are two interesting metrics regarding GraphQL queries. The depth. The depth is the level of nesting. well, the level, the deepest field in the query, and the width is the total number of fields in the query. We said graph model. Here is a representation of a dummy GraphQL API. And let's say, for instance, we have a type on the right-hand side exposing a stripe token field and a path in blue leading to this field. Well, since our data model is a graph, there may be several paths leading to this field. For instance, a shorter one here in red and a longer one in orange, effectively creating some kind of access control nightmare. I guess that's your turn.
So now we will talk about the escape magic and why is it hard to test production application. But it's a fundamental problem. It's not specific to GraphQL. Any application is hard to test dynamically. So first, only very few companies how they integrate automated dynamic security testing pipelines. This is becoming more frequent with SOC compliance and compliance in payment system and compliance in general. Secondly, most of security solutions use fuzzing algorithms. So sometimes fuzzing algorithms are really simple, but sometimes are really advanced. If you take, for example, ledgers and stuff, they will use a lot of fuzzing testing, really advanced. And anything that is coming to binary exploitation is about fuzzing, but API is quite different. And often security solutions do not pass the validation layer, and so they never test the business logic, whereas most of security vulnerabilities are present. So that's why we developed a unique algorithm that we call feedback-driven exploration that is specifically designed to learn about the application, about its business rules, and the way it actually organizes objects. This system was specifically designed to work on GraphQL, but we reached the state of the art in that field, and we are now battle testing it on different protocols such as REST or gRPC application. To explain it really simply, we will go to the next slide. So you can take a look on that part. You will see that you have way more coherent data than on the other one. So on the right side, you will find a query that is totally randomly generated. And on the other side, you will find something which looks like an UID, an email which is very likely to be gathered from the application. And you also have an injection in the password. So Escape is scanning in two different steps. There is the first step where we gather a lot of data from the application, trying to understand this business logic, and we will change a very few things after that to test about vulnerabilities. If some of you knows Nuclei out there with bug bounty testing, you can see Escape as like Nuclei on really, really strong steroids with this feedback-driven exploration algorithm. So, as Gauthier just mentioned, GraphQL is a graph, and resources are all organized as a graph. So it's becoming very hard to automatize that with software, because application can be very huge with federation and stuff. We today have algorithms that are capable of operating both deep and wide, and actually testing all paths, all parameters, and all objects in a GraphQL schema. That was not an easy journey to manage this recursive behavior.
Yeah, so we build a complicated algorithm, we make it run on the internet with what we found. More than 40,000 alerts, which we will review one by one right now. No, just kidding. Here is what we found grouped by categories. In this big list, there are GraphQL-specific errors, vulnerabilities, and some kind of vulnerabilities that has existed ever since APIs existed. For instance, publicly available stack traces, unsafe routes, GraphQL injections. Let's take a look at this first three to begin with. Here is a GraphQL server which has its debug settings still on production, and it's about 12% of all GraphQL endpoints we tested. And why is it a vulnerability? Because some stack traces just dumps library versions. For instance, this server is using a deprecated library with a very critical, not high, CVE on it. The next one is unsafe route being public, which means, in fact, that the mutation, which can affect, edit data on a server, are missing some access control. Last but not least, we found many SQL injections. They are still there. One bash command injection, which means we can just run code on the remote machine. And 3 server-side request forgeries. We were able to intercept machine-to-machine communications to leak some API secrets. More on that later. Now let's jump into the GraphQL-specific vulnerabilities. We group them in 4 categories: API brute forcing, denial of service, API schema leak, and unsafe public operations. The first one, API brute forcing, leverages a feature, or 2 features actually, named batching and aliasing, which can, by design, group several GraphQL requests in a single HTTP exchange, making the whole exchange faster on the internet. Because some web application firewalls count requests at the HTTP level, it allows an attacker to run some kind of brute force attacks, to run, for instance, 3 or more login attempts in a single HTTP request, effectively bypassing rate limiting.
So here's a quick conclusion of the consequences you can have through brute forcing. So stolen user account, because you can actually brute force and say, okay, I will try 10,000 of PIN password tries in one request, and because I bypass the rate limit, and you can extract sensitive data using such techniques.
Yeah, and this feature, aliasing, when coupled with another feature named GraphQL file uploads, can lead to a modern version of zip bombs. We named it GraphQL bombs. For instance, let's consider uploading a single file of 1 megabyte, but if we reference it 1,000 times in a request, with a 1 megabyte HTTP exchange, we are able to create 1 gigabyte of work on the endpoint. So we can add GraphQL bombs to the list of consequences. This time's for you.
Okay, all right. For the second vulnerability, we'll talk about denial of services, and we will take fragments as example. So fragments is another feature of GraphQL. You can see that as a function if regular programming languages. So I may ask you what could go wrong if you have a language that is recursive by design, if you implement a function in it. So let's get an example of that. So this is a very simple example. We are declaring a query which call a fragment X. We are declaring a fragment X which call fragment Y, and so on. So congratulations, you made your first infinite fragment recursion loop. So this is an updated stack trace. So most of JavaScript-based and Python-based engine don't want to actually cover these cases because it's handled by the language's safeguard on recursion, but still you get an interesting stack trace. Let's think about compiled languages, because this thing is in the GraphQL RFC. So compiled languages such as Golang and Rust do not support this at all. So if you use Rust here, my team and I made Rust more secure because we published multiple CVEs. So this is a different attack, but still on fragments. You can check on GitHub advisory if you want the detailed explanation. So we're only disclosing the ones that do not affect GraphQL RFCs and are related to the implementation itself, depending on the languages. So in that specific example, just to be quick, we nested a lot of fragments together, and we lead to memory overflow and took down any Rust server almost instantly. So as I said, we made a lot of contribution to JavaScript engine and Java engine, which is used by most Fortune 500. And so at Escape, we do run into a lot of 0 days, but we are always reaching GraphQL Foundation and maintainers first before disclosing. Consequences of denial of service could be an API availability for some time and a total API shutdown. So the third interesting vulnerability specific to GraphQL is schema leak. So GraphQL provides some introspection capabilities, but you can disable this feature to hide your schema. But with another GraphQL feature, field suggestion, you can rebuild the schema from scratch. So with file suggestion, any misspelled query will be corrected to something that actually exists in the schema, even if the introspection is disabled. So that is an example of schema we reconstructed through Clairvoyance. Clairvoyance is an open source package that you might be using already if you are doing bug bounties on GraphQL. We contributed a lot at Escape on this package. This is totally open source. So here is a practical example. In that specific schema, on this side you have the schema that we found through the introspection, and someone just thought it was interesting to hide update time inquiry because it wasn't protected, so we changed the password, and someone was not happy. Yep. So we highly discourage considering security through obfuscation, because pen testers are always capable of restituting such information. So we can see the consequences of schema leak, access to unauthorized function that you previously hide, and easy compromission, because if you have an update admin query, you just have a backdoor in your API.
We also found a shovel full of publicly available information in 2 big categories: PIIs, personally identifiable information, and tokens, API, machine-to-machine tokens. Among those, in the PII category, we found a lot of email and phone numbers, which in this case could be false positives, like support address emails, support phone numbers, sales phone numbers, etc. But that was never the case for passport numbers and bank account numbers, which are far more critical. On the other hand, we managed to dump a lot of machine-to-machine tokens, like Amazon Web Services tokens, Google Cloud Platform tokens, private RSA keys and certificates, and auth tokens to Adobe, Asana, GitHub, and even one ChatGPT token. All these GraphQL-specific vulnerabilities, these 4 categories, can be linked to the more common WASP top 10 vulnerability classification that Tobias showed a while ago. For instance, the DOS and complexity issues fall under the API 04 category. Access control fall under all the access control OWASP top 10 categories, 01, 02, and 05. And security misconfigurations and information disclosure fall into the API 07 category. To sum up what you could read in the report, we found more than 100,000 public GraphQL APIs on the internet through GitHub searches, Google searches, only OSINT. We narrowed this list down to 1,000, a bit more than 1,000, based on two criterions. They need to be publicly accessible without any kind of authentication. So that's the unauthenticated criterion, and have their introspection open, which means that we can get the whole schema from the API without needing to reverse engineer it with the suggestions, for instance. All the vulnerabilities you saw, some are GraphQL specific, which can be the most devastating ones, but some are as old as the internet. And denial of services are possible quite easily by default because GraphQL engines feature no hard limits on query depth and query width, which can lead, in the case of a GraphQL gateway, to a single point of failure. Because you're able to down the gateway, you're able to down all the infrastructure. You can scan the QR code to download the whole paper. You will get more information on the 46,000 alerts we did not detail, which makes a lot of pages. And
All right. So let's see how we are trying to make the web app ecosystem more secure, so not specifically GraphQL. And that is a few surprises we talked about at the start of the talk. First, we can tell you about GraphQL Armor. GraphQL Armor is a completely free and open source package that is a one-line installation for JavaScript-based engines. You can remediate to a dozen of GraphQL-specific vulnerabilities such as alias limit, character limits, depth limit, and field suggestion, and so on. So check that out if you are like a GraphQL developer or trying to improve in bug bounty. So just type GraphQL Armor, and if you want to make a contribution, we always accept contribution. So as I said, we recently extended our algorithm to REST application. So we did the exact same report on REST application. So we published a website called apirank.dev. We ranked every APIs on different criteria, but so we scanned again the internet trying to find unauthenticated and public API. You have, for example, Spotify, SoundCloud, etc. So we had in mind that if you come to choose your next payment solution, you could choose between Stripe, checkout.com, and so on. So we ranked every API using different criteria such as security, so compliance with OWASP top 10, performances, so pure speed, reliability, and design, is your application commented, and so on. And we still found an interesting token in all these APIs, GWT, emails, and because it's really interesting because it's super recent, we found a few OpenAI API keys. For the numbers, we scanned over 6,000 API. We found a bit less of vulnerabilities this time because we didn't add the GraphQL specific vulnerabilities. And if we have some DevOps writer, you also have the technical specifications.
And last but not least, we are launching a completely free API Security Academy, which can be accessed through this link. It's a platform to learn about API security using both approaches. First, a red team approach, so you get to learn about a vulnerability. You get to learn how to exploit it. And then you take the blue team approach. You have to patch it and effectively prove that the vulnerability is patched. What's interesting about this site is that it runs entirely in your browser. You got a full Node.js development environment working in your browser through web containers, so it can work completely offline. Thank you for your... no? Not yet? Ah, yeah. Here is the details of what a lesson looks like. It's a complete integrated developer environment with a file system, the explanation of what the vulnerability is, usually small. Yeah, what's wrong? Yeah, small servers with one specific vulnerability. Yeah, so take a look. It's open source, it's on GitHub, and it's currently on beta. Please file bug reports.
So that's all for today. We're still hiring if you are interested in cybersecurity, software engineering, or full stack web development. We are based in Paris. So if you want to visit France, that could be a good opportunity. And there is our handles if you want to add on LinkedIn, send a mail, and maybe meet again at some conferences. Thanks.
Thanks. Thanks, guys, for traveling to be with us here today. That was great. Does anybody have any questions? Hand in the back, coming back. Keep it up. Where was the hand? Yes.
Hi guys, thanks. So first of all, your research is based on the APIs with which all have introspection open, right?
Yes.
So would you consider disabling introspection a must in this case as a step one to protect the API, and how much would disabled introspection make your work more time consuming?
So as I said with schema leaks, even if the introspection is closed, we can reconstruct the application. So I won't go too deep in this part, but so we contributed and made Clairvoyance open source. Most of the code is written by escape guys, but you could always, with some complex NLP algorithm, fall back to rebuilding a complete specification. Even if the field suggestion is closed, there is some heuristics available out there, but that's another stuff.
So basically, you consider disabling introspection a security for obscurity, right?
Yeah,
okay.
It doesn't
Thanks.
work. Security by obscurity is not recommended at all. You shouldn't consider it.
Also, if your API has a front end, the front end will contain some GraphQL queries that you can already take as a base of knowledge to create more complicated queries.
Any other questions? Looking up at the balcony. No? Okay. Are you here for the rest of the day
Yes.
and hopefully the evening? Thank you so much to Gautier and Swan. You're not forbidden to receive gifts, hopefully.
Thank you.
Yes.
Thank you very much.
Thank you.
Thanks.
Thank you. Here you go. And next, we are welcoming to the stage Veronica Schmidt and Emlyn Butterfield. Veronica is assistant professor at Noroff, and Emlyn is head of computing and program lead for the Bachelor in Digital Forensics. And they're here to talk to us today about IoT medical device security. If you've ever been left alone in a room in a hospital while you're waiting for a healthcare professional to arrive, there are many gadgets to amuse yourself with. Veronica just said that's why some of us don't get left alone. Yeah, just tell them you're a hacker and they will send the doctor right away. They won't leave you alone. So as we move to exploit IoT and new technology to provide healthcare to an aging population, how do we strike a balance with the security part? All right, and with that, we are up and running. Let's have a hand for Veronica and Emlyn.
Hello. Okay, so he kind of used my real name, which it's generally just V. My mom calls me Veronica. So if you come talk to me, just call me V. It's easier that way. So, like he said, some of us don't get to be left alone in a cardiologist's office anymore. I did 3 years ago when I came to Norway the first time. I don't anymore. I think it's because they Googled me. So we're very excited to come present some of the research we've been doing at Norway University College. Some might say it's a bit of an unhealthy obsession that I might have. But let's introduce ourselves. So I'm V. I'm an assistant professor. How do I get time off of work? I bring my boss with me. I am a PhD student currently, actually studying how to build robust logging for forensics and incident response on medical devices. It's a dirty job, someone's got to do it. I'm also involved with DEF CON and the biohacking village and a lot of other things that don't really matter, but I'm also a cyborg. It's probably the thing that I'm the most proud about. I have my own walking, talking ecosystem.
Good afternoon. I'm Emily Butterfield. I'm Head of Computing for Norway University College and Program Lead for our Digital Forensics Bachelor Program. Both Veronica and I come with industry experience working with law enforcement across the globe, and really come with a passion to try and find out what evidence can we get back from any devices we look at, from the entire ecosystem, not just from a computer, not just from a mobile phone, but from absolutely anything. And that's where this kind of talk stems from, I think.
It is. I still remember the first time that I asked the question of my cardiologist, do we use pacemakers and defibrillators to determine time of death? Firstly, he looked at me strangely because I'm asking questions about determining death and asking super technical questions only to be told, no, we do liver temp, which I thought was very silly at the time because we have something connected to a person, yet we use liver temp that is accurate in a ballpark. So, what can you expect? I hate to disappoint you, we do not have the tech and the equipment that the public sector has. I'm on a budget. Emlyn doesn't want to give me lots of money, so no, we do not have the technology. The fanciest thing you're going to see is some AI-generated art.
But we would love access to all of that information and systems that were on the keynote this morning. But I think a lot of what we've done at the minute is very much not on a budget, but it's completely achievable by anyone. You'll see as we talk that actually it's specialized, but at the same time, it's not specialized.
No, so let's manage expectations right now, right? I'm not going to probably show you something that's going to blow your mind. I was as surprised as you were, but we're here to share some of our research. So what are we actually going to be talking about? If you've Googled me, seen some of my talks, you know I have a soapbox. I need one because I'm short. But there is a difference between a medical device and a clinical device. We are not talking about the desktop, laptops, equipment attached to medical devices that connects into the EHR. It's not what we're talking about today. The devices that we refer to are the ones that are classified under the EU MDR and IVDR. What is that? It's a long, boring document that manufacturers have to follow, but it does define what a medical device is. Now, some of the things we've looked at is a patient monitor. Every hospital has them. If you've ever been a patient, you've been hooked up to one. Going to look at infusion pumps, some of the devices we've actually forensically looked at, CPAP machines, pacemakers and ICDs. Buy me coffee and I'll tell you why. Cardiac programmers. Very proud I now own 3 of them. How? Well, that's my secret. But there's a whole host. Can we show you every single one? No. I'll probably take up your whole day. But we are going to try and cover some of them.
I think the key thing for me was, I never thought about medical devices until Veronica came, and she'll explain why, and the kind of forensic significance that they might have, but also just the security implications from such devices and kind of the vulnerabilities that might exist and how they could be exploited. And the more you dig, the more you find, and the more you find, the more you want to dig, to the point that, as Veronica says, she owns far too many devices now, and each and every one of them has potential from both forensic and security perspectives.
I mean, by a show of hands, and I won't judge, who here has looked at medical devices in terms of vulnerabilities? I see some hands, so I'm not the only weird one. Welcome to my club.
It's the coy hands that come up that suggest that maybe we shouldn't be looking at them.
Well, we made friends with the public sector just in case I get arrested for what I have. So now we're friends. But what is medical device forensics? And yes, I had to bring in some memes because why not? Any good presentation has them. But medical devices seem like something that's foreign, sexy, new, high-tech. But it really isn't. But before I dive into the forensics of it and the incident response of it potentially and what it holds, kind of need to just do a retrospective of where we are. And the statistics here were published by the HISAC this year. So this is a study that they conducted. Now, these shouldn't surprise you. Medical devices have been vulnerable for years. It's only now that we're really talking about it. Now, 53% of these medical devices HISAC looked at and analyzed had at least one critical vulnerability which was remotely exploitable, which would impact patient care. Why is this important? Well, people like me are attached to these devices. We carry them with us. Now, if they have critical remote exploitabilities, well, it becomes a little bit different when someone's standing in front of you with those devices. Because there are many people just like me that potentially are walking around with a vulnerable device. Caveat, that doesn't mean I'm not going to have my device. I will rather have it than not have it.
But I think a big thing about these is that nobody's really considered the technology before. So vulnerabilities seem to have increased. I think we've discussed this many times. They seem to have increased, and there seems to be more security vulnerabilities now. But in all honesty, a lot of this is because nobody's checked them before and considered them as anything that needs to be tested, anything that needs to be secure. It was a medical device that gave support to different people in different ways. But now, when people start looking at the opportunities that they allow, then you can start seeing where are the holes, what can we do, how can we exploit them?
I mean, the vulnerabilities that have been found and disclosed in the recent years has increased by 59%. Now, that might seem like an alarming thing. To me, it's exciting, but because it means more people are doing what? They're looking at devices. I am always in support of knowing what the vulnerability is so that I can fix it, right? Better you know what's broken than know what is, than not know. Now, in a general healthcare delivery organization, one of the devices used most is an infusion pump, right? They're almost in every room. So 38% of the hospital networks are generally made up of infusion pumps. Now, anyone here know what an infusion pump is? right? They deliver some serious drugs like morphine or pain medication. So generally, they are things we don't want to be remotely exploitable. Now, 73% of the infusion pumps on the market have at least one remotely exploitable vulnerability. So you can kind of see that there are lots of reasons why we should be looking at these devices. I told you I'm going to have some amazing art. AI is fantastic. So what are some of the vulnerabilities? Well, these shouldn't shock you too much. These are things we've been dealing with in hardware manufacturing for years, right? We have 64% that is built into the software. But lucky for us, if it's in software, what can we do? We can fix them if we know about them. Now, medical devices, some might say legacy will always be a problem, and there is a reason, a real reason for it. We're dealing with hardware components. Hardware components within a human being's body. So how do you deal with a hardware vulnerability that's baked into a device? You're going to call in the patient and say, hey, we're going to cut you open because we need your device, even though it's a functioning medical device? No. There was a big recall on cardiac implants and pacemakers a few years back because a big vulnerability dropped. And because of a knee-jerk reaction from the manufacturer, they started patching without doing a real analysis and ended up bricking patients' devices. Security doesn't always get it right, because we did patch happiness. Ended up in patients having to come in and have physical surgeries, right? Thank goodness it's not rechargeable by means of that the patient has to recharge the device, because some of us would die. But you have to go in because it's a whole unit. So again, just finding a vulnerability is one component. Fixing it when it's hardware is much harder. But lucky for us, there is hardware vulnerabilities, and we'll tell you why it's a good thing sometimes. Now, there are different classes of medical devices. So who here has a health watch, like Apple? It's considered a medical device because it gives medical algorithms, specifically the cardiac one that does atrial fibrillation. Now, in those specific class 3 devices, there was vulnerabilities found. But I think the more concerning ones is the classes of devices within people's bodies, or attached to people's bodies, or on hospital networks.
You can see we practice this really well.
We don't, ever.
So what we need to think about is why are these vulnerabilities important? I mean, it looks sexy from a security perspective, saying that there's vulnerabilities in systems embedded in people's devices that are embedded inside their bodies. But from a forensic perspective, which is kind of a big part of where we're coming from, is these vulnerabilities allow evidence to be collected, but also because they can be exploited. Maybe those devices hold the forensic evidence that maybe prove, and this is maybe Hollywood style, but prove how somebody died. Maybe somebody hacked into the pacemaker and managed to overpower the pacemaker and blow them up, whatever it might be. But maybe that evidence exists somewhere. Can we capture that evidence? Is it obtainable?
You've really gone Homeland there on us. So who here has seen the Homeland episode called Unbreak My Heart, I think it is what it was called, where they have a patient monitor in the president's room, you know, and they managed to find his serial number and did this whole sophisticated hack. That hack is not as unplausible as one might think, right? So anyone that does medical device security will tell you that that day people's heads were on fire. But no one considers DFIR. No one considers that these devices that are on a hospital network might be the foothold onto electronic healthcare records. We know cybercrime is motivated by what? Monetary gain. How do we get more money? We sell data. Now, electronic healthcare records is one of those things that's very lucrative for cybercriminals to sell. And these devices are medical devices. They're functionally built not to be secure, but to give treatment and record clinical data. Therefore, they're actually a rich treasure trove for cyber criminals.
Now, the challenge we have is, where do you get the devices from? You can get dead bodies and drag them into your office and chop them up and pull out what you need. You can potentially go and source devices from different places and hope that they have information and hope they have weaknesses that you can try and exploit.
So in South Africa, it was fairly easy. I had a friend at a coroner, and by law, they have to remove the pacemakers and ICDs because they go boom in the incinerator. So have a friend, call a friend is helpful, otherwise your old friend eBay. Shockingly enough, very easy to obtain devices now. I think I've got the algorithm down to sit and wait. Now, I am not saying do as I do. In fact, I'm saying don't do as I do at home, right? That's the disclaimer. But most of our devices are sourced currently, since moving to Norway, from eBay. And one might think that you don't get devices from there, but you do. I don't know if they fell off a truck. Don't care. I just want to be able to hack into them, do some forensics, and take it from there.
Now, you'd think forensics on medical devices. If you've never performed forensics, it might sound a little bit fantastical, if that's a word, potentially. But in terms of medical devices, can we use the same techniques? Do we have to advance techniques? Do we have to use the fancy things that we saw in a keynote this morning? Well, the answer is kind of no. Realistically, what we're looking at is normal technology. Normal being technology that's been around for a long time. It's just maybe used in a different way, and therefore we can extract the same data from them as we do from computers, mobile phones, applications, whatever it might be, and still get all that data back and make use of it. We can use old techniques just in a new way.
I think that was probably one of the most disillusioned I was when I looked at pacemaker data the first time, because it looks sleek. It looks like it's got some new technology because it uses machine learning. It is able to keep my heart beating. It's able to keep me upright. All that amazing things. And then you open it to come to disappointment that it just looks like a micro PC, like microcomputer with some components. And it's not as fancy as you think it is. But it's important understanding what's under the hood, because people are intimidated by doing work on medical devices. And that's the purpose of this talk, is to kind of demystify these devices and say that it's actually accessible and easy. Well, not easy, but it is doable.
But don't tell everyone, otherwise we won't be able to get funding for future research.
Okay, so because we're academics and in forensic sciences, we have to come up with a process that kind of sort of follows a pattern that's repeatable, reproducible, and that we can document. So there's three things that with every device that we've looked at that we've kind of had to use. We've had to upskill to be able to do some medical engineering, or just normal engineering, but having to look at the device to figure out, is it still working as it should? There's no use doing forensics on a device if the data you're generating is coming from a flawed device. It doesn't help us document what's on the devices. But it serves another purpose. It helps us reverse engineer the hardware to potentially understand how we can interact with it. Because obviously there's many vulnerabilities on these devices that can be exploited. However, we need to find the door in, as was said this morning, jump the fence, that would leave the least amount of breadcrumbs behind, because it is forensics.
Then we get into the forensic side. How do we extract that information so that we can make use of it and present it and analyze it and use that in wherever we're going in the future? Now, you've got to think these medical devices are implanted, they're embedded. If somebody dies because something's happened on their medical device, then that's a criminal case, and therefore we have to do things properly because it's going to go into the courts later on. So we have to consider, just as we did on the keynote this morning, all the different steps of the forensic process. How do we extract? How do we analyze? And how do we do it in such a way that it's repeatable? Now, medical devices offer an additional challenge of it's not always repeatable. Sometimes we have to really destroy the device, and we've seen destroyed devices to be able to get the data back, and somebody else won't be able to replicate that later. That is just a challenge that we have to deal with in the future.
But I think it's a challenge that IoT sometimes faces as well, is that by means of actually getting into the device, we end up destroying it. We void warranties. I have realized now that every device I have opened, there's no way it will ever be used as a medical device again. It's labeled for non-human use. Because why? I'm not certified to open them up. If I was certified to open them up and I could do it in a process that retains the integrity of the device, that's different. But that certification will have to be done for every manufacturer, every device, which, as you can see, for digital forensics won't be a real achievable. I mean, I'd love to, but some manufacturers are nicer than others and will play ball, and some just generally don't. But the final one is probably, how do we visualize the data? Right? Because it's medical data, it's not data as we know. So unfortunately, we can't use our nice commercial forensic tools. They don't know what to do with the data because it is in unique formats. And better yet, they come in different shapes and forms. No medical device is exactly the same. There is a pattern, but they are different. So it's coming into creative ways of either building your own visualizations or using clinical open source software to visualize data to reconstruct what that data is.
I think this is one of those, it's a team player thing. Because not everybody will understand how to get the data from the device, how to connect to it, how to get it on a low level, so that we can perform the forensics, and then in particular, understanding the clinical side of things. I mean, some of that data, I think you need to study a long time as a doctor to understand parts of it and to make sense of it. So sometimes we'll have to pull in other people to assist.
But I think the important thing is forensics people know how to work with data, right? There's lots of instances of data that we don't understand what the data means, but we can take it visualized to someone, like a medical examiner, that can then look at the data in a format that they're used to. So I get asked this question regularly. Why are you so weird that you want to do your research? Well, I have a device. I'm curious about it, because if someone's going to get killed, it's going to be me. Right? No, I'm joking. But it is the connection from the cyber world to the real world. So it matters because people's lives matter, and it's only a matter of time before we see this exploited in the wild. So let's look at a device. Let's look at our first device, which is an implanted cardiac device. What this purpose of this device is, it'll kick you in the chest and wake you up when your heart decides to misbehave, in short. Okay, that is what's in my body. Well, an upgraded version. I'm obviously not going to show you guys what my device looks like. Like I said, a room full of hackers. No, 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 I know better. Well, sure. I'm happy to be the ethical, what do you call it, research bunny that you can try and attack my device. I might even tell you how. No, I won't. So what does forensics look like on an implant, right? We know DD, we know RAW, we know EO1, we know all those kind of forensic images. Hate to disappoint you, that's not what you're gonna get. So depending on the manufacturer, so this is not applicable to every single implant because every manufacturer has their own way of doing it. A lot of them has a, what we call a PCB file, the programmable database file. That contains all the information. Most of this information currently is clinical. So how many times was treatment given? The firmware is on there. So it is not in the traditional format that you would expect it to be. It's in a proprietary binary format. Currently, the easiest forensic way to get a full capture of that without having to destroy the device or take it outside a human body is to use a cardiac programmer. They have the ability to actually grab that full binary image. But then you're kind of stuck because it's a proprietary binary format. Now you have to engage with the manufacturer. And that goes right about 50% of the time. So it's either a maybe or a not. European manufacturers tend to play ball nicely. The US lot is a little bit of a different kettle of fish. But this PDB file is super important because it tells us whether the patient received specific treatment. It tells us what the settings are and when last it's been changed. But that's basically the extent of an implant.
I think with medical devices, if you've ever done phone forensics, and we're talking Nokia 1100s, Samsung D500s, that kind of age of device, we're probably at that same stage now where there's lots of different variety of formats. Each and every one of them essentially needs decoding in some way. So if you love hex, then this kind of stuff is perfect for you because you can pull it apart and find out all the evidence that's inside of it, and not many people can currently.
Yeah, but before we move on, so you've seen the device that's a cardiac implant. You get similar devices like that that goes for deep brain stimulation. They are not quite the same as a cardiac implant. There's one key difference. The brain stimulators actually are rechargeable, which means they aren't restrained to the amount of storage they have. So some of them might actually have a file system or an OS on them, where the cardiac ones are reliant on X amount of CPU cycles, so they can only do certain amount of data storage for a certain amount of time with some security, sadly, because we don't want to have a new device every 3 years. I like going in it once in 17 years, but that's how long this device lasts. This is an interesting story. So this device is my dad's device. He asks himself the question what he did to deserve me as a daughter, but we've built a whole scenario around a patient dying using his data. Now, he kindly gave me the device after I was done with it. I just think he didn't trust what was done on the device, so he didn't think that it would work anymore. But the CPAP machine, you would think, is less foreign than an implant, right? Lots of people have CPAP machines. So basic tools that we needed was a specific torque screw, which is one of the things you find that you need. And then, depending on some hardware, to be able to do some hardware acquisitions.
Now, the disappointing or exciting, depending on how you look at it, the data's on an SD card. It's on an SD card using a standard file system that we know how to analyze, we know how to extract. It's nothing new, it's disappointingly nothing sexy. However, it is easy to get hold of. We can use traditional forensic tools and techniques to extract the data, to analyze it, to interpret it, and do some parsing of the information.
Yeah, I think the shocking part was that the claim is made within the FDA documentation as well as the manual that they offer secure delete. Now, if you living in the EU, you know the right to be deleted, the right to be forgotten, GDPR, and data limitation. So I decided, well, in all things in science, let's see if we can get some more SD cards on eBay and see if we can do good old-fashioned data recovery. Now, the findings on that study, or, well, I say study, a little project that we had, we found that it was not secure delete, but just a basic formatting that was being done. So if you know the FAT file system, you know data recovery can be fairly simple. So again, we were able to actually recover patient data from previous patients that sold the cards. Now, the machine itself, depending on the version you have, may contain a Linux file system. Good thing about this, it is encrypted both at rest and in transit. But for the sake of not totally destroying the device, we didn't want to go take the board apart. But then Emlyn lost them because he took his eye off his luggage in Germany. So the device is somewhere on eBay for sale.
But it wasn't just my device, it was all my clothes and everything. But that's a different story. As soon as you touch this device, as soon as you start opening up, you void the warranty, which means it's no longer usable for and fit for human, I was going to say consumption, use. And that's a challenge in itself. I mean, the SD card holds information that's really of interest, that patient data, the recoverable information. That's perfect. But to get to it, we're now voiding the warranty, which kind of brings us back again to the early days of phones and extracting that kind of data.
Yeah, so in terms of we can destroy devices, I mean, I can open them up and void them completely. But in a real-life digital forensic situation, are we in the business of taking devices that are potentially super expensive, like MRIs, off the market because we've now done forensics on them? No, I don't think anyone's going to be happy with us, least the hospitals won't be, because those are machines that they replace once in a while. So the key thing to this research is, can we get in without compromising the integrity of the device itself? Now, in terms of this one, we had a spare one that we wanted to destroy and open, and we found that it had the ability to connect to the board itself, which a lot of these devices have. Now, security professionals will go, why did they do something like that? Well, because diagnostics has to happen, debugging has to be happening, and technicians need to be able to debug and figure out if a device is working as it should. Now, that means once you've got physical access to devices, that becomes super easy to get into them, because we know potentially this is a component of the design. So a lot of the times, this is just to give you an idea, we have to face many decisions, like how are we going to go in, which way is going to be least destructive, which way is going to yield the evidence or the information we want to have. I wish I had the answer to say to you, it's X, but the forensic answer is, it depends on the device.
But if we can be lazy, we'll be lazy. And so we'll just look at the SD card. And from that, we'll pull out a variety of different information that gives us everything about the machine, its settings, its patient data, structures of treatments that have taken place, which includes...
So when we opened the device, we found an EDF format. Now, EDF format is a format that's been around for as long as I have, and there I've just given away my birth year. But it has been around for ages. And you find well-documented things in sleep studies, because what is the CPAP machine doing? It is monitoring your sleeping pattern as well as your breathing. So in applied data science, because there's a lot of studies done, we could find a documented structure, and it is in ASCII. So it's totally human readable and in plain text. So you can imagine on those SD cards that we recovered the data, we could actually do a trend analysis on who the patient is, how they slept, what therapies they get, what device it came from, and all these very nice pieces of information. Now, forensically, these things are important because we can determine whether anyone has tampered with data, but we can also determine whether or not a patient received the equal clinical therapy that the setting says it should receive. So if someone's changed the settings, there is indications that it's happened, so we'll be able to say that a patient did not receive appropriate care. Again, I'm lazy, Emlyn's lazy, so if we can find code to do what we need to do, we will. Again, went to the applied data science space and found some nice Python libraries that pass this information out and gives it to us, because we like to do things easy. But why reinvent the wheel? So using MATLAB, if you really want to, you can actually put out the signal, the medical signals, and determine the sleep patterns. Or you find open source software that does it for you. Now, in the CPAP community, when you do a little bit of OSINT and research, you actually find that patients got fed up with the care and the denial of access to their data, that someone built a tool that parses the information so that you can make informed decisions, right? And this has been maintained and is freely available and can be used to actually visualize the data. Now, our students at North University College actually does medical device forensics, and this is from a scenario that I built around tricking my dad's machine to not sense his breathing, so I could simulate him dying and put him under a tarp and take photos. But we are able to say what is the settings and the fact that the machine didn't respond when he had an event. Insulin pumps are the same. There's a huge underground community of patients that have built software that allows you to read data off an insulin pump.
So essentially, it uses the FAT file system. It's on an SD card. Even if things are securely deleted, it's all perfectly recoverable, and we can find information about past patients and all the information that was stored on there about their treatments, the kind of system that was used, and also their PII. So information that's very specific to them. You need specialist knowledge, I think, to be able to parse that information. This stuff, it means nothing to me. Veronica spent a lot of time looking at this, but it's just about sleep patterns. But the medical experts will understand this and have more perspective on it.
Yeah, I might be the weird exception to the rule. I want to understand how these things work. I necessarily won't go testify in court. Just to what Emily's referring to is knowing where your line is. I did consult on a case involving a pacemaker where in a murder case, short story, because I can't give you the long one, is the fact that I was able to verify date and time on the device. I was able to verify the integrity of the report that was taken. But I was not allowed, even though I'm a patient since 19 and I understand these things at heart, testify to what it meant, whether the patient receives the appropriate therapy. A medical specialist was brought in, but because we could confirm the integrity of the data, it made his job a lot easier. This was probably the most fun I had because I went totally old school. It's a device I've never come into contact with in South Africa. It's a patient monitor network bridge. So it bridges into the hospital network and connects to other devices, because what can go wrong? One would assume that because it's a network bridge that it is fairly secure. Now, if you look here, we can see that it's running Tordidex, kind of gives it away. So we know one avenue to go research, but we also know that they've got some proprietary software on there.
I think this fits nicely back with the CPAP machine, in that there's a hell of a lot of information out there that you can find just by Googling. Everything from people that have decided to pull apart the system before, to look at the file data, to understand and interpret that information and build tools that will parse that information, to people that just want to share, people like Veronica who just want to share information out there about what the device does, what it's capable of, and what it's made up of. So this is where your Googling should really be the starting point for a lot of these kind of research purposes.
So I bought this device because it was a late night shopping. I tend to do that half asleep, and then, surprise, more packages. My husband's not impressed because he's just another one. I'm like, don't ask questions. First thing I did was I did a good old-fashioned Google. I go to the manual. Now, one might expect these manuals aren't readily available. Midwench is your friend. Every technician and nurse practitioner puts these manuals on that they've scanned from their hospitals, because what happens to manuals? They get lost. Right, so sharing is caring in the medical world. And those things contain a heck of a load of information. It's actually overwhelming. The FDA publishes some of the documentation. EU MDR does as well. So if you read around the redacted black areas of things that's proprietary and confidential, you can get a gist of what is going on this device. Now, once we did the research and I identified which board it was, it gives me access to a lot. I found some known vulnerabilities. Now, everyone should be, or perhaps isn't, with this Spectrum meltdown attacks. Now, this is on a hardware board, so this means that it's not something that can easily be mitigated. Now, 2 out of the 3 CVEs, this board was impacted. Why do we care about this in forensics? Like I said this morning, it is our hold into a device. It's the hole that we need to climb through. Now, this is just one example. Most of these devices, when you start looking into the boards, you will find a whole host of vulnerabilities on them.
And I think this kind of research is where the fields of forensics and security really cross over. So looking for vulnerabilities, exploiting vulnerabilities, was not necessarily something that was ever in forensics, but is really important to get into these new systems and new devices, which is why the community needs to grow and expand and share information about how to break into these systems, how to then attack and steal the information, not only from the perspective of someone exploiting it for nefarious purposes, but also for legitimate legal purposes.
So just to be clear, so one of the things, I belong to the biohacking village in Vegas, and I am the cavalry, which does a lot of this research. Ethically, by the code of conduct that we have, when we find exploited vulnerabilities that haven't been reported on, we will report it responsibly to the manufacturers. Now, that might not sound as fun, but because we are dealing with human beings and potential things that can impact harm, we do tend to report these as we find them and work with the manufacturers on fixing them. So we are very much for responsible disclosure. None of these that we are showing today or the methods are undocumented. These are well-documented things that others have found in these devices. So in terms of this device, it soon became apparent that perhaps we weren't going to be able to use our forensic tools. I was very shocked to find a bunch of USB ports at the back and decided, well, what's going to happen if I put a USB mouse and keyboard in? Am I going to be able to break out of the kiosk? If you've ever tried to break into kiosks or get them to go, sticky keys is normally your friend. In this instance, it was literally pressing the Windows button and poof, there's Windows saying, hi, I'm here. What can I do for you? But then, doing more research, I realized that this was a version of Windows I haven't seen before, because it is embedded Windows. Who here has ever done PDA forensics? That's how old school it is. So it is, I think, Windows CE 5 on this specific one. But the developer guides gave us a lot of information on potentially how we could connect to this device. As you can see, we've got Ethernet, USB that we already saw without opening the device, GPIO, UART, L2C, and it had an SD card. They tried to hide it under the board, but it was quite apparent that there was something there. So kudos for trying. This thing was very perplexing because even when I did the forensic acquisition of the SD card, it soon became apparent that it doesn't have a C drive, it doesn't have a root drive, it's not the traditional embedded Windows that I knew. So I did some more research on the developer tools and realized there's a whole host of tools that offer me access into the device. Why? Because developers need access to program these boards and work with them. So what did we do? We used the remote viewer, right? It's not very sexy. What it does, it takes connection from your PC to the device and allows you to use your computer as a screen. But it gives you access to the operating system, which allows you to do a whole lot more. And I didn't need a password at all. It was literally just identifying the IP address of the device and then connecting these two pieces of software up. Now, we did the acquisition traditionally. I'm not going to tell you for the SD card how we did the acquisition. That's boring. But we used the update tool. Now, this specific board has a tool that allows you to do a cold boot, a warm boot, or actually save binary images of the data contained. So the operating system, the file system, the bootloader, and all of those there. Now, this is probably the closest we're going to get without having to rip the board apart. So this is what we did. It's a binary image, right? It should be readable. Sad was my realization that it wasn't, because it was also an operating file system that I've never encountered. Who here has encountered TFAT? Yeah, I didn't either until that time. So everything was a proprietary binary format that was not in any ways or means viewable. But reading a little bit more, I was able to build the same Visual Basic environment and use open source code to translate the binary images into file system files.
This gives your logical files, and we can then use our standard forensic tools to do the analysis. Same things were found on the SD card, maybe slightly simpler to get hold of the SD card data, but the information is there, and we can do standard analysis, pull the information out. We can find things inside of the registry, because it uses embedded Windows. The registry is there, giving us things like typed URLs, information about systems, applications that have been run also.
So one of the things, once we had that, and we had both images, we could compare with fuzzy hashing and hash values to confirm that what we're seeing on the SD card is in fact a backup and not older data, so that we can verify it. But this acquisition was done without ever opening up the device. Now, one might think Windows Registry, they all feel and look the same. Embedded Windows are slightly different. It's a compact version. So your registry editor that you're using now won't work. And as such, we needed to make use of an older version of Registry Editor to actually look at the data. So These are the core findings from the Windows registry that we were able to recover. While some of them are useful, there's not a lot, but this is because it's a resource-constrained device. We have the machine GUID or identifier, so we can identify each machine uniquely. We had limited USB information, like 3 or 4 entries, and not to the extent that you can get today. Typed URLs were also first in, first out, so not a lot noted. Again, resource-constrained devices.
Again, traditional forensic techniques can be used. It's nothing new. It's just used slightly differently. This information was easily extractable, I think it's fair to say. It was well documented. There was information all over the web that you could search for to find, and that seems to be the case for a lot of the medical devices. And making use of that open source intelligence in the first place gives you a lot of access to the information that's in the back end.
And again, the fact is that secure delete is not, as we would know it in forensics, it is sometimes just a factory reset or clearing out of the root directory. It's not really anything comprehensive, so general data recovery would work. How are we looking on time?
You can leave some time for questions if you like.
Okay, well, we're going to finish up and then we will take some time. Okay, so future research. We've got a heck of a lot of equipment that's just come in that we need to look at. I love the fact that I'm paid to actually look at medical equipment. It's amazing. It's probably an unhealthy obsession, but we have more devices that needs to be examined. Up until the point that I get banned from eBay, that is where I will source my devices, and then I'll find alternate routes. But the acquisition process is fairly still hardware-based, right? It does leave some destructive elements. And it is going to be that way because of how the devices are manufactured and the fact that these things last 10 plus years. The newer devices are actually, according to the FDA cybersecurity guidance, now having to come with the ability to be forensically acquired. That's going to probably be another 5 years before we see those things in market, so the future is bright, and we will see more capabilities to do that.
But what we see is a range of different operating systems and a larger ecosystem. So whilst we're talking about physical devices now, what we also need to think about is the applications that connect to those devices. Are they on Android? Are they on iOS? We can then again use more traditional forensic techniques to extract that data, and it is so rich. It's terrifying, I think, about how easy it is to gather that information and make use of it.
Once you have access to the physical device, the operating system is your friend. It will give you all the information. And a lot of the time, the manufacturers don't understand the underlying operating system or even the file system, because the rules of how data is stored and deleted is handled by the file system, and the operating system plays a role in that. So whilst they build applications on top of these layers, the rules still apply from the file system to the operating system. But it might be shocking to know that my cardiac patient monitor is running on Android, and it's got an ext file system. It's things in forensics we know. So it's nothing new, it's nothing strange. But I think the key finding is we need more people to do research into this, right? We need the task team to take on board and actually consider medical devices as a problem. Now, we have to acknowledge that medical devices does not have a functional requirement for forensics and security. By virtue of this, they're not ever going to be massively pushed to be secure. I got asked the question, V, would you ever want a username and password on your implant? And the answer is no. Why? Because when I'm having a cardiac issue, I don't have time to give a username and password to the nurses and doctors. I want them to have access immediately. So, availability of devices cannot be overtaken by security.
But these devices will never be the linchpin within an investigation. They will be something that adds information, that maybe gives a timeline or a suggestive intelligence that we can then use and correlate with other information. So we're not suggesting that these are going to be the golden bullet, but they will assist. And they are a different source of information that is generally overlooked at the moment.
It's more a circumstantial evidence. It adds to the case. And the same with the implants that have been used in court cases. They're not the determining factor. They're simply in support of other evidence. Now, how do you get started in this? A lot of OSINT. You research, right? If you can Google, you can find a manual. You might even find it on the manufacturer's website where it asks you, are you a doctor? And if you lie good enough and you just say yes and you lie from your location, a lot of these manufacturers give you the technical manual, the operator's manual, and the clinical manual. What more do you need to understand what the device is doing without ever opening it?
The caveat there is do not lie. Veronica is just suggesting one way of gathering information, and she is not encouraging people to lie on applications.
I think the biggest thing that I've learned from these things, and that this was kind of the inspiration for my PhD, is the logs suck on these devices. They absolutely don't contain any robust logging of any means or form. The logs are riddled with vulnerabilities. We saw lots of things where sensitive data has been disclosed. Let me tell you, every medical device, as I stand here before you today, contains logs with printed plaintext JWT tokens, exposed URLs, app keys and secrets, patient data, because they are built with clinicians in mind and they're built with debugging in mind, not for the purposes of security or incident response. And with that, you are rid of us, unless you have any more questions.
Thank you, Evelyn. And V. I see a hand at the back. Yes.
Thank you very much for the talk, very interesting. Was wondering if there's any personal health medical device with a wireless module, say Bluetooth, that you managed to find a fully remote exploit to. Because that's the sexiest part, right?
So I have a unique take on vulnerabilities. I'm going to stand like this because I can't see you. One of the things is, we found Bluetooth attacks. We found wireless attacks. Heaven knows my device has got what they refer to as telemetry C, which is wireless, which communicates in plain text. I have RF as a backup, and I have Bluetooth, right? All of these modules will become vulnerable at some point. That is the sexy part of it, but I think where I get excited is, can I tell what I've done to compromise the device? Is it, I find a vulnerability, I exploit the vulnerability, but then I want to do the forensics on it to determine whether or not there's logs, there's artifacts. I only have to get in once. But to fix things and make things more secure and do forensics is a bit of a continuous challenge. And that's kind of where I enjoy doing what I do. But if we find vulnerabilities, we do responsibly disclose it, and we do disclose mechanisms in what we find for forensics. Like if I find no access to logs that I've connected onto, that is something that we will tell the manufacturer and suggest that they add in future releases, if possible.
Any other?
So some of the devices I do have, I legally cannot yet publicly disclose some of the vulnerabilities due to the fact of the manufacturer and working with them to fix it, because I'm under contract. So whilst I'd love to be able to do these demos, legally I don't, and I am a visitor in this country. So keep watching the space. When that time runs out on when we can publish, we will publish.
Hi. So what I was left wondering is, speaking of the cardiac programmers, you said you can basically dump the data from a device. Can you do that covertly, or do you have to be in such a close proximity that basically you can't just sniff everyone's data around the room?
So I'm going to tell you why I'm not allowed into a hospital room alone anymore. In South Africa, we managed to do a man-in-the-middle attack with exactly that by, just sniffing the authentication between programmer and patient. The doctor didn't assume anything else of me because they don't think that it's something to be worried about. The old telemetry that most of these devices have as a backup is in plain text, right? So if you at the appropriate time is able to sniff the traffic, you get the golden authentication token. That means that every device that has, from that manufacturer, you could do a replay attack. There is actually well-documented research on that from other manufacturers. I can't say their name because I'm going to get into trouble again, but there has been a mass recall and things like that. I remember attending Black Hat where a friend of mine, Billy Rios, was doing an attack with a programmer that they were able to put malware on. Because a lot of these cardiac programmers run a Windows variant.
Well, to answer your question, the close proximity is still required, generally speaking.
Actually, not that close anymore.
Not now.
Not, but then yes. The range, I think, is 50 meters now, and increasing ever so often as technology increases. But we do call them the stars have to align attack, right? It's not just that has to align, it's a bunch of other elements which makes these attacks still unlikely. It's more likely that my device accidentally goes into what is referred to as VVI mode, which it thinks it's being debugged, and it's constantly going to go. We have a lab on campus that interferes with my device and actually puts it into VVI mode because of the electric interference, which means it could potentially drain the battery. There's other attacks of magnets being used to put it into debug mode. But like I said, they find something, they improve upon it in the next generation. But if you have a medical device, it's going to be vulnerable, if not now, in 2 years when someone has got nothing better to do and they found a vulnerability. It's a thing we need to become comfortable with.
Time for one more question. Anybody? I have one question, more on the forensics in general. Tool validation has been a big thing in some jurisdictions on the admissibility of forensic evidence. So, yeah, of course, in decades gone by, NCASE, FTK were the big two in North America anyway. Is tool validation a problem when you're talking about gathering evidence with various open source tools and developer kits and so on?
I think if you can show that it is reproducible, repeatable, and that you've tested it numerous times, then it becomes easier to be admissible in court. It is not your traditional forensics, right? Whilst the analysis is, the acquisition can and will be disputed in court. This case that I consulted on, in fact, the manufacturer picked up the device, dumped the data, and destroyed it because it's biohazard, right? But in any investigation, we would never destroy a device that we're looking at. But that was their process, and it was approved, and the courts accepted it as such. So it's still developing. We're still making lots of mistakes, and the more it gets tested in court, the more we will be able to refine the processes. But a lot of these things probably won't pass the test for going to court yet, if I'm honest with you.
And that's where research needs to come in, and more people being involved in research and looking at other devices just so we can get the validation done appropriately.
Thank you very much, V and Emlyn. And now we have a break. Remember to pick up your t-shirt if you pre-ordered and get one already, and you can get blue t-shirts, pay what you want. See you in 15 minutes.
so this was great. I spent like an entire afternoon just watching through a bunch of these on 4x speed, looking for like, there's the thing I can use, all right, screenshot. There's the thing I can use, all right, screenshot. There's, it's mostly Roadrunner and Wile E. Coyote.
Thanks for those of you who have joined us for the next round of talks after the break. People are slowing down as the day wears on. You're being flooded with information and cinnamon buns. So Ian Fox is a fellow Canadian from Waterloo, Ontario, and he also did his first talk at DEF CON last month in the OT Village. Yeah, ICS OT, SCADA. Yep. So there we go. Take it away, Ian. Here's your mic.
Oh, thank you. Excellent. All right, thank you very much. Yeah, as Ryan said, I'm going to be talking about OT, ICS, SCADA, whatever you want to call it. This is some work that that my team at work has been doing, and I thought it was interesting. So even if it's not directly applicable, I think to what you do, I think there will probably be maybe some ideas that might inspire you. As you said, I'm from Canada and moved to Norway because apparently I'm fond of cold places. Working for an OT security startup here called Omni. And so you've heard me throw this word or this acronym around a lot at this point. What is OT? So if you're not familiar with it, OT or operational technology is basically anytime that you have computers and digital systems interacting with the physical world. So maybe that's in a factory setting like this. Maybe that's with some medical devices. Maybe you've got like a big robot trying to catch your enemies. And it has a lot of similarities to IT security, but also a few things that are different. Similar to with the medical stuff that we just saw, a lot of it's very old, hard to patch, not necessarily designed with security in mind, and that can lead to some interesting challenges. Particularly what we were looking at was context and visibility for risk assessment and for incident response things. So in a lot of these networks, they were built like 20, 30, 40 years ago. So maybe you have some network sensors that you can see, your standard like IT things in the network, but there's going to be gaps there. And if you're an incident responder and you see an alert come in on an IP address, maybe you see that it's critical, but you don't really know why. You see that, but it's fairly opaque. And so we were trying to figure out, is there a good way that we can provide some more insight into this and maybe show someone who's responding, well, is this something that I really need to care about? Is this controlling, like the main drill on like an oil rig or something like that? Or is this controlling like the AC unit in the break room? If you're an incident responder, that can be kind of handy to do. Or the other sort of thing that we were trying to do here was help with some risk assessment, because if patching is really hard and patching is expensive, you want to really focus your efforts where it's going to have a meaningful impact. So what we found was that these network sensors are really good for the IT stuff. They can tell you there's we see the service is running on this IP address. It's got this vulnerability. Not so good for showing you what that thing was actually doing. And that's where we started looking to some alternative sources. So for the example here, maybe we can see that there's this controller thing, and we might have some guesses as to what those wires are going to, but we're not quite sure. So where can we look to try to fill in these gaps? And as you might have guessed from the title, the answer turns out to be a lot of docs. There are some other tools that we have as well. You can go to the site and actually walk around and see. Maybe you can do like some Nmap scans or something like that. Though in OT, you have to be kind of careful with that, because again, a lot of these systems are very old, very brittle. Something as simple as running a scan too aggressively could knock the whole thing over. So you want to be careful with that. You also might interview some site experts, but again, these guys are very busy. It takes a lot of money, a lot of time. And so we wanted to try to build up as good a model of the site as we could before going to these sort of more expensive methods. And for that, we turned to docs. So our plan is to convert these docs into a machine-readable format, build a graph from them, which I'll talk a bit about what we use that for, and then use that to answer some questions either about risk assessments and trying to pinpoint where we want to spend effort, or on helping give incident responders an idea what they're dealing with. There are a few types of docs that we'll go over in specific. Some of them you're probably familiar with, things like network diagrams or risk assessments or functional specifications, which are basically just like a Word doc describing how the system is supposed to function. Others are a little bit more specific to the sort of physical realm. Things like P&IDs are piping and instrumentation diagrams, and they look like this. Each one of those icons there represents an actual physical, either like a valve or a tank or something like that. And then the lines are going to be frequently like pipes between them. And so this is laying out how the whole process, the physical process, is going to work for that particular part of the plant. And there's a lot of good information that we can pull out of these. In particular, as mentioned, those symbols are generally kind of standardized. So that might be a valve is the little thing in the middle there. A lot of them have tags, which are labels associated with them. And as we'll see in a second, there's some semantic data that we can pull out of those. And the relations between which valve is attached to which tank is controlled by which computer is of interest as well. Tagging is the first thing that we decided to look at, because pulling text out of these documents is much easier than trying to understand the actual picture information, at least as a starting point. A lot of these were actually just scans of PDFs, but even those you can at least do OCR, and there's some pretty good tools for that. And these tags, once you have them in text format, you can actually pull some information out of them, and it'll probably look different from site to site, but for sites there is generally a pattern to it. So for this particular standard that they use for this site, it's laid out into which system, which subsystem, which part of that subsystem, and then even has some information about if there's any parallelism and which instance of that item it is. So when we're looking back at something like this. Maybe this is like, we can see it's a valve, and maybe it's valve 1 versus 2, and you can see sort of where it is on the thing there. In this case, 84 is maybe it's the electrical system, and ELJ is the code for a junction box, which has something going on. So the first step that we did was we took these docs, we put them through just some standard like off-the-shelf OCR tools, and then you can start doing text search on them. As you noted, or as you might have noted, the tags are very, very standardized, which leads itself well to regular expressions. And so you can write a pretty easy script to say, given a tag, look through all of the documents that we have and find which documents are related to this piece of equipment, because the tag identifies like a piece of equipment. Or given a document, give me a list of all the equipment that it talks about. And we're dealing with a lot of docs usually, so this is something that already can start to narrow down your search when you're trying to figure out what's going on with a particular system. And of course, we've got to use LLMs because those are the new buzzword. And we can use those with especially the more sort of text-based functional documents where it might describe what operating system a computer controlling a valve is using in just like plain text. And so we can start using some, again, off-the-shelf tools like LangChain and like Llama Index just to start building up the graph, which we'll see in a second. Template matching with just like some standard OpenCV stuff can also be used to start matching the symbols in those diagrams. So here's an example of the obligatory LLM. Can the system that is associated with this tag run with one of the meters offline, which is maybe important for your risk assessment? And it says, yeah, we found this document, and the glowing green chemical thing can run even if one of them is off because it's got one built-in spare. And this is really what we were trying to build. And one of the things that I think is most interesting and more broader than just OT sense is that graphs can do a lot for you. There's a lot of really good tooling available around doing queries and doing sort of reasoning and algorithms on graphs. And so we wanted to try to take advantage of that. So the graph that we built had nodes for more traditional IT things like network devices that are running instances of software which is affected by CVEs and are connected to networks. And then from some of the diagrams that we had, like those PNIDs and other similar ones, we can see which physical things they're connected to, which functional assets flow to which. If there's a tank that's flowing through a pipe to a different tank, then if you can affect the upstream one, then that'll have an effect on the downstream one. That's good to know. And from some risk assessments that we found, we also found that we could tie these functional assets to consequences. If the tank holding the fuel is ruptured, then people from the companies have probably done a risk assessment and put like a severity on that of there's this a high environmental consequence or something like that. There was still a lot of manual work here, but using some Python, we were able to reduce some of that boilerplate, and then we basically just put it in a commercial, like off-the-shelf graph database. So a lot of this, I think, is not too difficult to reproduce, and I'll have some links at the end to some of the software that's handy if you want to try doing something like this yourself. So a very small segment of the graph ends up looking like this. You can see that we've got the sort of turquoisey nodes are computers. PLC in this case stands for programmable logic controller, which is controlling some robotic arms, a conveyor belt, a self-destruct thing because we're looking at the Acme TNT factory. It's got to have one of those by law. And HMI is a human-machine interface, but again, basically just a computer that's connected to that network there. And so we can start asking these graphs some simple queries like, if I'm on the HMI, which physical devices can I control? And there's the graph database does that pretty quickly, and it can find us from, it translates that from the query down at the bottom there. And so we can see, all right, if I'm on this HMI, I can control the robotic arms, the conveyor belt, and the self-destruct thing. Or if I'm trying to do a risk assessment on a particular piece of equipment, maybe if I'm looking at the self-destruct thing, I can ask the database which IT devices have a path to be able to control this. So you can see how that would be useful for some of these higher, more destructive physical things. We can go even further and tie this to things like consequences from those risk assessments. So if I'm an attacker and I'm on that HMI, I can say, show me the fastest way to cause some kind of consequence that would be bad. But more exciting than that would be to actually set some agents loose on this graph and see what they can find. So with, again, just another simple Python script, you can have it start at one of your computer nodes and have it look for any networks that are connected to that device, other devices on that network, and then find CVEs on those devices which are remotely exploitable through the network, and sort of build up your graph of things that you have control over. And if they have a CVE which gives you code execution, you can keep pivoting from there. If it's a CVE which can cause denial of service, then you can potentially disrupt whatever physical assets are being controlled. And so you can sort of build up this blast radius from each of the devices that you can start from. And if you do this to enough of these, you can start to build up a notion of which nodes come up again and again, and sort of maybe try to pinpoint which specific CVEs are going to be the most impactful to patch. If you can only patch like 3 things, maybe we can find some hotspots in the graph and try to get the most bang for our buck when patching. Because if you run the whole thing and you can see what the most valuable assets are, take a few of the CVEs out and run the whole thing again, you can compare the CVEs in context and actually see how much more secure your network is afterwards, rather than just looking at the the CVSS score. And there are tools that do this as well. So we built one, but there's also a couple of open source ones from MITRE, which again will be linked at the end of this. And they do basically the same thing. So here's an example of that. We can. I told it that we're looking for routes from the engineering station in this chemical process plant to anything that will have a high environmental cost. And you can see that it finds some devices, looks for the networks on those devices, goes and discovers a bunch of stuff. And eventually it finds the self-destruct flamethrower that's reachable through some steps, gives you the attack path there, exploit the CVE, pivot to this thing, and then you can control it, and it has the environmental consequence of high. This was I think I already sort of went through this verbally, but again, basically if you run this differentially, if you run the whole thing with different aspects in the graph, maybe if you put in like a firewall, or if you take out some of the CVEs, then you can see how specifically that'll affect how difficult it is to find these paths and how easy it is to get from a likely entry point like the internet to some sort of unwanted event like a high environmental consequence from something in a risk assessment. But this is still pretty early days. There was a lot of manual work here, which we're trying to get down. The diagram parsing in particular is something that still requires a lot of manual labor, and so we're looking into some more computer vision-y things to try to deal with that. Of course, I'm sure there's more we could be doing with LLMs going into the future. And a really big one is connecting to more data sources to deal with drift, because these documents are generally, there are some from when the equipment gets updated, but of course, when you're dealing with systems this big and having contractors come in and whatnot, things are always going to change, and that's not going to necessarily be reflected in the docs. So something that's still to be tested is how close these models actually get to real life. And that's another place where I think it's a good starting point, but you still do want to use those other tools like the site visits and interviews to sort of refine it afterwards. These are basically all the tools that we used in the process. And I'm happy to, if you're interested, go into sort of more specifically how we chained them all together. But I'll just leave that up for a second. SciCat, the one at the bottom there, was the MITRE one that was doing the attack paths, and that's kind of fun to play around with. But the two things that I really want to stress and that I thought was most interesting about this was, one, there's a lot of untapped information in docs, especially when it comes to some of this information that you're not going to find just by doing like a network scan or something like that. And I think that's probably true of some other areas as well, where if you think of all the information that you have available to you when you're solving a problem, frequently there will be some that's a little bit harder to get to, but might give you some good insight. And two, graphs are great for modeling complex systems. There's been a whole bunch of really good open source software made for these, and like theory done on them with algorithms and things. And I think it's a tool that we should not be forgetting in this world of LLMs and neural nets and things. We've got some other tools that are, I think, better suited to some problems. So I want to say thanks to the people that were doing this work with me, and that's all I have for now. So I don't know if I have time for questions, but I'll be sticking around for the rest of the day as well.
Yeah, let's move on, but come see Ian. Thank you, Ian. Next up is Andre Lima. So for those of you, thank you very much. For those of you who are on the red team side of things, hacker, code cracker, weed whacker, you're wondering, where's all the red team stuff? Well, here it comes. Save the best for last, maybe, if that's your jam. Andre Lima is a red team operator and researcher from PwC. We're very happy to have him back again. He was here last year, and his talk was one of the most popular according to the community feedback, and we got to have that red team. We got to scratch that red team itch. So check out his bio on our website as well, and you can find a link to a number of his other talks and research. He's very involved in sharing and giving back to the InfoSec community in various ways. So we will, in any moment, dive into automation for red teams, how to improve our workflows, because we are simulating attacks as red teamers in a time-boxed engagement, and the bad guys don't necessarily have those same time constraints as we do in a consulting setting or as an internal red teamer inside a business. Wireless password is Skogstin20 exclamation. Would you like me to type it in for you? Introduce yourself, Andre.
Hi everyone. My name is Andre Lima. I've been a pen tester, red teamer for more than 10 years. And yeah, really enjoy doing the research and everything. And thank you.
Let me get this out of your way. Give it up for Andre.
Thanks. Just bear with me for a second. There is a weird delay between the mouse and anyway. Okay. So this is Red Team Automation, Infrastructure and Payload Development. My name, as I was saying, is Andre Lima. I work at PwC Norway. Have been doing this for 12 years. Red Team operator, researcher. Have worked around the world, in Portugal, Australia, and now finally settling down in Norway for sure. And yeah, you can reach out to me on LinkedIn. If you want to check some of my previous presentations, that's the link. And if you're interested in what I do and want to follow, just I'm on X as well. It's still weird to say that. Also, I'll be sharing the slides in the end, so don't worry about taking pictures and all that stuff. You'll have those in the end. So yeah, today we're going to talk about, because I understand there's a mix in terms of, in the audience, in terms of experience. So I'm going to do a little intro on Red Team infrastructure. Then I'm going to talk about my implemented solution, big FYI, work in progress. But I'm going to talk about the infrastructure, payload development, and future development that I want to do on it, and some conclusions. So a little intro into Red Team infrastructure. Just some design considerations that you should have, and the reason why you will often see this type of architecture whenever Red Team infrastructure is mentioned. The things you are looking for here are resilience and concealment, and the whole point is if you have a payload and it's reaching out back to a C2 server, you want to have the resilience of having more than one redirectors. Those redirectors do nothing more than redirect traffic to the backend server. That could be a C2 server, that could be a payload server. And what you want is, if the blue team is able to detect that type of traffic and it flags it as suspicious and it tries to block it, you want to have a list of options, in this case, the list of redirectors. So if you block redirector 1, it just automatically moves on communicating on redirector 2, and then if something happens on redirector 3, and so on. Now, usually what you want is to have some sort of separation of duty. Again, gives you more resilience, but you'll often have this logical architecture regarding, for example, your payload, and then another one for the C2 server. and then maybe another one for the phishing infrastructure, for example. You want to have these separated because you don't want to have the blue team just block one IP and all of a sudden it blocks your entire infrastructure in terms of functionality. But there is a problem with this, which is, as you might imagine, if you are tasked with setting this whole infrastructure up, then this becomes a huge load of work, and you do not want to do that manually. I love sysadmins, but this is not the job. So I do prefer to spend my time hacking. So yeah, the solution is obviously, given the problem that too much work, instead of spending too much work in sysadmining, you probably want to take some of that time and actually put in to what is more valuable to the client and actually do more hacking in that sense. So automation is definitely the way to go. Now, just a quick note on why this type of projects is interesting. Multiple tech options, different design options, very customizable, new tech integration. One of the things that I've always loved to do, even though I'm more connected to the security industry, is to go randomly to conferences, IT conferences usually, where sometimes developers, infrastructure, whatever, and just learn about new technologies and often wondering, how can I integrate that into what I know and how could that help me? And in that sense, it is incredibly interesting to just go deep into some of the technologies because obviously most of us understand, for example, the concept of DevOps, but have you actually ever gone deep into one solution and tried to actually have it work? So this is why this type of project tends to be like super interesting. You just learn something new and immediately you might have new ideas. I don't know, for example, Mojo is a new language, but on the surface, if you look at it, you might just quickly put it aside as, oh, it's just an AI language kind of thing. But actually, when you dig deep into it, it doesn't relate to this, but it's just an analogy here. But when you dig into it, you start realizing that actually it's a full purpose language. And if you understand how much quicker it is and how it does it, you can quickly have the idea of maybe redesign Hashcat. I don't know, Hash Cheetah or something. And down the line, maybe that's an interesting project that might come up just because you had the idea to go to a conference and hear about Mojo, that seemingly unrelated. So if you want to read more into this, there's a lot of technicality in terms of what software to use, for example, in the redirectors. There's more considered dumb redirection when you usually go OZ layer level, level 3, 4, where you're thinking about IPs or maybe a TCP, UDP, that kind of redirecting. But then there's also the considered smart redirection, where you tend to, it's usually something related to, it has the ability to read into the layer 7. So HTTP protocol, look into the bodies of the request and decide what to do. Sometimes EDRs and specific tools that sandbox some payloads will do requests and will identify themselves in the agent or in whatever HTTP header, and you might want that flexibility. So in that sense, you might want to use something like mod rewrite. In my case, I'm a minimalist at heart, so at this point I'm still using IP tables, but later down the line, as I see the need for it, I will definitely improve it. So yeah, definitely some really good references. Now I'm going to talk about the implemented solution. Again, big FYI, ongoing work. So basically, it comes down, in terms of infrastructure, it comes down to a Python wrapper that runs Terraform to set up the infrastructure, and the Terraform in itself has Ansible as well for provisioning. So if I need to install an Apache server kind of stuff that will be done with Ansible, but setting up the whole VM and redirectors and all that stuff will be done with Terraform. The reason why you want to wrap this up in, in Python is that you will require, for example, when I do DevOps, I'm using GitHub Actions. And what that means is I will eventually down the line have to trigger a workflow. And you can do that in the GitHub, using the GitHub API. To do that kind of stuff, I need not only information that is given to me as output from Terraform, namely the public IP addresses from VMs, but also, obviously, the API keys and everything to communicate and set up the whole DevOps, which I'll talk more ahead. There's also I want to integrate Uptime Kuma, that's K-U-M-A, just because it looks interesting, so I got into it. It doesn't mean necessarily it's the best, just FYI. But the whole point is you want to set that up, usually with Terraform and Ansible, and install it. But then you need the API, the Python, to again reach out to it through the API, through its API, to feed it the servers that you want to monitor and how you want to monitor them. That's a bunch of Python requests that you do. So these are some of the options that it does. I'm using the click module on Python. It just makes things a lot easier. And that's an example of the thing running. It's not that interesting seeing it live. It takes a lot of time. A lot of time as in 10, 15 minutes, maybe, depending on the number of redirectors, but on the Terraform applying part. But yeah, and those are some of the tools that I'm using GitHub Actions. I'll talk a little bit more ahead about those. And yeah, just to talk a little bit about the option to go Terraform infrastructure as code. This is one of the things I really like about Terraform. It's just infrastructure as code. So when you need to back up your infrastructure, theoretically, all you have to do is git push your the code itself. There are very good people that use Jenkins, for example, which is completely plausible and a very good option. But to be honest with you, it's mostly a personal preference because, first of all, I look at Jenkins and it looks like something coming out of the 90s, and not a huge fan. But also, on a more practical side, I'm a minimalist, and I want to decrease the amount of sysadmin work that I have to do. And the worst thing that I want to, the thing I don't want to happen to me is for me to come into the office thinking that I'm going to do some really cool recon on a client, and then all of a sudden there's a new critical CV on Jenkins, and I have to patch it, and I patch it, and I figure out it's broken. Now I have to fix everything up, go figure out where the last backup was. I'm not doing that. So yeah, really huge fan of Terraform, and yep. The next one is just the integration between Terraform and Ansible. Just to clarify, it's not like I'm an expert in these technologies, but the feeling I get is that Terraform tends to be better at deployment of infrastructure, and Ansible tends to be better at provisioning, installing software, and setting the server up. So there's a lot of discussion. Some people think one is best in the other, but some other people think the combination of the two is the best. And quite honestly, I've used it and haven't had an issue yet that I could think, oh, maybe I should have used more one or the other. And then there's some notes on infrastructure security. The most important thing when you have such infrastructure, especially deployed automatically, is you want it to be secure. Bear in mind, these are software that will be running the C2s and so on that give you access into actual infrastructure. So you want to be very careful with that and make sure you know what you're doing. One of the cool things, very easy to manage SSH keys throughout this whole thing. The version I'm using Azure as on the backend as my cloud provider. And the firewall is the network security group, NSG, and that's just a little part, as you can tell by the left column, there's a lot of number of lines there. Just an example, the first one will limit, that's for the resource C2 redirector. So for the redirectors, I will only allow SSH, and to be honest, I think pretty much all the VMs. I will only allow SSH from the operator public IP address, for example. And then the redirectors will accept both port 80s and 443 from anywhere. But there's a little trick that I will explain actually now in the misdirection part. What does that mean? So this is one of the cool things about these types of projects is that you can become very creative, and because there's no right way to do things, you can just do whatever you want that you find interesting. And one of the interesting stuff that I thought about was, if you notice, when I run it, there's some debug information there. You can tell there's a client network range that I supply. Now, the reason I do that is for the infrastructure to be able to tell the difference between what's coming from the network, the client network range, and what's coming from the rest of the internet. Now, if you're coming from the network range, the client network range, what you will see, and you try to access one of the IPs, in that case the 112 redirector, what you will see is the actual backend. I think this case is the payload redirector, so it's the payload backend server. That's the Apache that is there installed. Now, if you try to access it, I used my phone because I'm on 5G, so it's just easier to don't have to set up anything or just to move places. So just from my phone, you see a cannoli recipe, which is good if you want to play around with the blue team and just misguide them a little. It's always useful. So yeah, it's one of the interesting stuff that you can pull off by having these solutions. So in terms of DevOps, building the tools, compiling the tools that we use very often. I'm using GitHub Actions, and again, it's not like I sat down and I played with every single one of them out there and decided the GitHub Actions is the best. Not the case at all. But I like using, if I'm using GitHub already for my repos, for whatever, I use it for project management as well. It's kind of handy in that sense. When you push stuff, it automatically creates stuff in there, which is super convenient. But if I can have all my tools in one spot, unless there is an amazing feature on some other option, I will tend to have all of them on one spot and just make my life easier. So that's why GitHub Actions was the option. Now, that being said, I've noticed some difficulties in writing workflows, just some things that don't sit perfectly with me. That might have changed since then, a few months that I checked that. But for example, the latest version, I want to say, of Visual Studio that you can use to build tools in GitHub Actions is, I think it's 2019. Whereas if you're using the Azure DevOps, not sure if it's Azure DevOps or if it has a specific name, don't remember, but then it allows you for the more modern 2022 version. And overall, it kind of makes sense that Azure would make a better option for building at least C# tool, .NET stuff. So it kind of makes sense. So it's definitely something that I want to try and give it a go, but that's later down the line. So you can see here just an example of a workflow running. Now, if you look at the green sign over here, and you see here it says manually ran by Andre. I was confused when I read that because I never read that. I mean, I ran it manually, I think, the first couple of times when I was testing the thing. But ever since, it's just the infrastructure, the Python wrapper that runs it. But I then realized on the GitHub documentation that you can manually trigger a workflow run using the GitHub API. And that's basically what I'm doing. That's a call, a part of the Python wrapper, where I'm just obfuscating my API key, of course, but overall it's just more than obvious stuff. It's just some Python code that runs, triggers the workflow. Now, after you build a thing, the naming convention is you create what is called the payload. In this case, it's called artifacts. Now, in GitHub Actions, and I'm sure others, do provide input, not only input, which is useful here in terms of public IP addresses, but also allows you to define secrets. So if you want to put in your SSH key to then connect to the payload server and upload the artifact that you just built, then you do something along those lines. And yeah. Now, that is all about building your code. But when you're building your code, before building your code, you want to worry a little bit about the code itself. And the simplest example, you probably want to obfuscate stuff in it, but not to be easily detectable in signature-based kind of detections. So the way you try to do usually that is by using some sort of scripting capabilities, either PowerShell or Python, and you'll find a lot of very hacky ways where people will run scripts to find, for example, literal strings, anything between two double quotes. But if you think about it, that's a very hacky and bad way to do it. It can lead you, depending on the complexity of the software, to a lot of false positives. Interpolated strings is another type of strings that you cannot detect just by simply doing that kind of stuff. But also all types of details, like if you're expecting a keyword followed by, for example, if you want to update an in C#, you should, because the executable is actually IL code, intermediate language, and it keeps a lot of the names of the classes, methods, and all that stuff, namespaces. If you are looking like to replace a class name, and you're thinking about, let me look for the name ABC, but ABC might be like in the middle of a string, so let me put space ABC space. But then you can find examples where the program, where there's two spaces, where there's a line break, when there's lots of stuff. Bottom line is you're trying to do it the hacky way, which might work, but it's not the best way. And that's where Roslyn comes in. After doing this type of stuff, I thought Roslyn was just a compiler. It turns out that it's actually defined as a .NET compiler platform. And that sounds very fancy, but basically what it means, it represents C#. It parses the code, which, if you think about it, it's the best tool to parse the code and interpret it. And most importantly, it parses the C# code and it generates a syntax tree, which then you can navigate, and you will have all these different types that will define specific stuff that you will then easily be able to find class names, to find the instances where they refer to that class name, method names, whatever you want, literal strings, interpolated strings, and all that stuff. So the syntax tree will contain syntax tokens, such as keywords, literals, and so on, syntax trivia, all the different types. There's different types for different types of comments, for example, and syntax nodes as well, language constructs, classes, namespaces, and all that. So that is the power of Roslyn. Now, just a quick warning. It sounds like, I'm about to show you like a few slides on this stuff, and it sounds very straightforward, and it must be like easy to use. There's, first of all, like, but there's a lot of stuff that I'm not talking about here because this is not a Roslyn tutorial. But I will give you really good references of places where I learned a lot about it. One of the things is you can write very simple code and look at the syntax visualizer. It's not hard to get to it from the menu. I don't remember right now because I've done it a few months ago, and now it's always there. So, but ping me later. I'll find on my notes or actually look at it. But yeah, so you can click on stuff, and I think there I was clicking on Hello World, and it immediately jumps, the visualizer jumps into the type that corresponds to that object, which is the string literal type. This is just an example for you to start getting like comfortable with the types and understanding how it all nests in together. But in order, the oversimplification here is that I just showed this, and everyone is probably expecting to open Visual Studio and find it. You actually have to install Visual Studio SDK to do that. If that was the only thing, that would be cool. But so the NuGet packages to be installed, there are quite a few. Let's say 4 or 5, I have to check my notes again. But they basically contain information for types, classes, libraries required to analyze, parse, and understand the C# code. Then you have multiple objects, literal string, interpolated string, syntax trivia, all that stuff that you kind of have to get used to. So it's a good idea to actually take a look at the visualizer. There is also, I didn't put it here, I forgot, but there's also a URL, a website that does that offline. So if you don't have Visual Studio for whatever reason, or just want to quickly just go and check it, again, ping me later. Yeah, multiple workspace types, ad hoc workspace, MS Build workspace, Visual Studio workspace. Depending on what you want to do, you'll have to use different ones. And also understand just what a workspace is, a solution, a project, documents, how they correlate with each other, and then how all the objects then come into the document object. Then you have learning how to navigate the syntax, which can be done in 3 ways. Link is the simplest way. Sorry. But not great performance, which is relevant if you're writing an analyzer, which Visual Studio is running every time you press a key. But then again, for our purposes, it's not really that bad. There's also Syntax Walker and Syntax Visitor. And Link is actually something, because I find the Syntax Walker a little bit more elegant, but I've been forced to go back to Link a few times just because of that last sentence, insufficient stack to continue executing the program safely. Now, if you've ever programmed using any sort of recursion, you know that if it gets too deep, then you start having trouble with the stack. And that's something that sometimes Syntax Walker will trouble you, and you'll have to revert to some sort of solution on Link. Another issue is all those objects are immutable objects. And that's something that you hear and you tend to forget really quick. But what that means is every time you actually change the code through programming, it actually creates a new instance of the object. So if you're keeping the old one, which is very common, you then struggle with, wait a minute, I just changed this. What happened? Why is this not changing? And you just have to figure out that you have to use that new object. So just some really, really good resources, and again, conferences that I would usually not attend. Developer more, like C#, I think. I want to say programmers, developers, but seem very focused on C#, don't know. But and BSides Oslo, where Mark Randall and Eric Shearboom, I hope I'm pronouncing that right, but they talk about very deeply about it, and some other implementations that don't relate to security, but you understand the whole point of having these. Also, XPN has really good blog where he actually uses Azure DevOps. Which XPN is Adam Chester, amazing researcher. And actually, I do have the link for the syntax visualizer, which is that one, Roslyn Quoter. Again, I'll give you the QR code for the slides in the end, so you can access all this. So let's just show a demo of Roslyn. In this demo, it will just grab a seatbelt, and it will convert all literal strings and interpolated strings to capped uppercase letters. I'll just show you the code and everything. Just one sec. For some reason, it's taking ages to start. Video. Just 1 second, bear with me. Let me just try to kill Windows Media. Okay, so let me just try to. Okay, so I think it's running. Problem with the mouse, sorry for that. Okay. Okay, so this is basically the main code, and as you can see there, I'm loading the solution. It's going to just call, let us just run through it. So it loads the solution. That's the seat belt that I'm about to update and download. Then it creates an instance of the uppercase writer, which is an implementation of C# syntax rewriter. And you have those two visitors, interpolated string text and interpolated the literal string one. And all of those are executed once navigating through the whole syntax tree and calling out the visit method there. So then I just have to update everything, build the whole process, output the assembly to an executable locally, because again, this is all in memory, and then run it. And here you can see that I'm getting a fresh copy of seatbelt. And then I just run it. And you can see everything comes back in uppercase. That is very weird because I'm not moving it. Okay, okay. Now, there are some complications there. Things get trickier, I mean. The thing is, that is a very simple example, but it's the example, I wanted to show it because it's the easiest to visualize because of the uppercase, of course. But what you actually want to do is to integrate, to grab that literal string or interpolated string and put it inside a decode method. Not only obfuscate it somehow or encrypt it, but also put it inside a decode method. Now, what that means is that you have to write the code for the decode method somewhere. Now, depending on the software, that could mean inside a namespace, inside a class, and just write another method. But it has to be code that is reachable throughout anywhere that has a text that has been obfuscated. So it makes you think it's not that straightforward. So. Now, just to clarify some goals, what you want to have is fresh infrastructure ready to go, fresh payloads ready to go, simple to deploy, easy to manage. But and for future development, what I want to do is having the infrastructure timeout for auto cleanup, because ideally, you don't want to stress too much about bringing down the infrastructure and just have it, the engagement is ending in 2 months, for example. You just set a date and it does it automatically. Of course, more C2s. Everything that it's being done is the redirection and everything right now is through IPs, not domain names. So that's a part. But I've seen that you can actually buy domain names. Probably generate a few random ones to test it out, but there are tools that will generate, if you give it some sort of context in terms of naming of company kind of thing, it will generate a few random names that are kind of related to it. So it's a better of disguise, but again, you want to automate all of that. Support to HTTPS, still not done. Also, phishing, infrastructure support. I definitely want to add that. How long do I have? Okay. Now, a lot of people like solutions like GoFish, but personally, haven't had great experiences because the obvious thing about these types of tools is that you lose a little flexibility and control over what is sent. So a lot of spam filters will tend to become really good at detecting the minor things about how an email is developed. So you want to be very careful with that. And to that extent, I'm much of a bigger fan of developing the whole thing myself. Very quickly, Python code running that connects to an SMTP server I've done it in AWS before, but pretty sure you can do it anywhere else, to send an email, and then you control the whole body. That could be HTML, that could be just text, but you control everything, exactly everything that goes into that. And then just create the whole phishing site where you collect the credentials and so on, and make it look like something legit. Quick conclusion, good red team infrastructure design principles, resilience, security, easy to deploy, good payload dev principles, obfuscation, encryption is usually, not always, but usually an overkill. From experience bypassing EDRs, most of the times what you are actually trying, and it's really important for you to understand the goal here. What you're trying to bypass is automated static analysis, as in signature-based kind of detections. You can never stop a really good manual reverse engineer. So it might take them longer, but that's the point. You want them to take a little bit longer, but it's just for you to be able to then move laterally and get other machines. So it's very important to understand what is the purpose here, and more often than not, Zor encryption, Zor obfuscation, or encryption technically, with 1 byte key is more than enough. Code insertion to stop automated dynamic analysis. Don't have time, I would elaborate on that, so just ping me after, but IOC stripping, per compilation, per op, GUID insertion. You want to have that because you want to have the functionality of if something gets uploaded to VirusTotal, you want to be able to understand exactly which engagement were you on when you compiled that payload. And it's really good feedback as well for the client and for yourself. If you're in the middle of an engagement and one of your payloads gets uploaded, you know it's from this engagement engagement and not the previous one or something like that. So you probably need some fresh payloads. You only get that kind of feedback if you have these GUID into your payload. And then, of course, the kill switch. The job is ethical hacking, and there's a very important part on the ethical word. And that also means respecting the client's time. Now, a lot of the times you assume, oh, but my infrastructure is gone, like, what do I care? You should care, because when a payload is triggered, is executed, and it starts running, you need to have a kill switch. Otherwise, what that does is starts a whole bunch of red flags and tickets throughout the whole company, and you're just wasting people's time unnecessarily, as opposed to it just checking if it's the time of the engagement, if it is, for example, if it is running on a computer in the domain that belongs to the client. So you definitely want to check those things. And when you want to check, for example, for domains, you don't want to put in the actual domain of the client in the payload, because that's a hint that a client X might have been compromised. So what you want to do is, if you understand password storage, is pretty much something like that. It's a bit extreme to salt it, but what you want to have is a hash of it. So you grab the domain where that computer belongs, you hash it, you compare it with your hash, and that's only if it matches, then you run. But if you take anything from this talk, let it be the following. Never send a human to do a machine's job, Agent Smith. So I hope that you've learned that today. You can grab the slides on that QR code. Again, I'm reachable if you want to check my previous presentations. So thank you very much for coming.
Thank you very much.
Thanks, man. Really appreciate it.
Yeah. We all appreciate it too. Are you sticking around if people have some questions?
Yes.
Fantastic.
Dinner as well.
Yeah, here for dinner as well. Great. So that brings us to our last but not least talk of the day. It's going to be another hard-hitting red team talk from Morten Ingesen, founder and CEO of Covert AS, a security consulting firm specialized in offensive security, pen testing, red teaming. He is also a two-time winner of the Master of Cybersecurity Norway from the competition from HackCon. So it's a fun event. And he is going to talk to us today about AI and how we can use presumably LLMs that have been all the rage in red teaming and offensive security operations. And after that, we will have we'll wrap it up with some closing remarks. Prize for the lucky and skilled CTF winner. And then hopefully many of you will be joining us downstairs for drinks for 1 hour approximately, and then we'll come back up here for dinner with tables, and we'll get rid of these chairs and set up for dinner, which will be at 6. We had to move out of Smelteverket, which was the original plan, due to damage from the recent flooding, which is still not repaired. So we'll hang out in Pokalen for those of you who are joining for the evening. Have some drinks, and then we'll come back up once the furniture is changed for dinner. Good to go?
Soon, perhaps?
Soon? Yeah. Okay. That's a good answer. We still have some retro t-shirts. This is the retro from last year. If anybody wants to pay what they want, any number 0 and above is recommended. And if you pre-ordered a shirt, then please go pick it up, and then we will sell the remaining shirts as well from 5 to 6 if anybody wants this year's shirt in luxuriant brown. It's called mocha. But you can be the judge of that yourself. Yes. All right, give it up for Martin.
I'll try my luck at kind of hitting the button with lag. It's like playing Counter-Strike at home. All right. So thank you so much for having me. And I know that I'm standing between you and beer. So I realize that's bad for me, but I'll try to get through this. I also tried to go for the most buzzwordy title. I think I won, if you can agree. I also tried to go for the longest one. You know, I'm fairly like in the lead there. Unfortunately, the GraphQL guys beat me, so I have to do better next year if I'm accepted, obviously. But yeah, that's going to be one of the parameters. I'm sure. So. Briefly about me, this is me before I started learning about AI. Now I have a beard and the deep depression. No, I'm just kidding. I grew up always wanting to be a programmer. So I love programming. I've done that my entire life, as far as I can remember at least. So I figured out I wanted to do some education. I wanted to go down that path. And suddenly realized, you know, information security is way cooler. Started playing some CTFs, as Ryan has mentioned. I won some of them. I also played with people here, which is also very cool. I started working as an information security consultant. I've been doing that for, like, professionally for 7, 8 years. Been playing CTFs for 10 or something. And decided 2 years and 9 months ago to start my own pen test company, as Ryan also mentioned. Now, if you're coming here, like what's important to mention here is I don't have like a PhD in AI or something. So if you're here and you know a ton of stuff about AI, I'm sorry. I'm going to try to look at this from kind of a practical approach, but also kind of forward-looking. Andre touched on a lot of cool topics that I'm also getting into, but I won't spoil it. The point is, I drove here, so I didn't have a chance to bring it with me, but I have a picture of it because this is going to be fairly high level. I'm a dad, so yeah, sorry. Now, the title contains the word offensive security, and so I want to try to define that quickly before going ahead. Now, back in the days, we kind of separate between the red team and the blue team. The red team being the people, you know, attacking stuff, and the blue team being the people defending them. And I know we have a wide variety in the audience here today. So that was kind of the tradition, and now suddenly. Red teaming has become much more than just being the guy who attacks or the people who attack. I think this is kind of a typical buzzwordy thing in the information security space, but suddenly red teaming is kind of what. It doesn't matter what you're doing as long as it's always red teaming. You're doing vulnerability scan, it's red teaming. You're port scanning something, it's red teaming. You're, I don't know, writing a report, it's red teaming. So we're kind of moving away from the word red teaming, because when I talk to clients, they say red teaming, but we mean widely different things. And if I choose like 5 people here right now and ask them like define red teaming, well, we'll get 5 different answers. I'm certain of it. So we've shifted to the kind of more adversary simulation, emulation stuff, but also, namely, the name offensive security. So offensive security is basically just attacking stuff. It's penetration testing, I guess. It's and they go ignore the company named offensive security. They just messed it all up. But yeah, luckily they renamed. So that's That's good. As offensive security practitioners, then, we gain access to a ton of data. I'm not sure if everyone realizes that when we do penetration testing or are doing a security assessment or something like that, but the amount of data we get access to is pretty large. And the amount of data that we're able to process, like manually for us, is very limited. I don't know, like if there's any penetration testers here, like how many file shares have you read, like for hours? Just reading files, trying to figure out documentation, trying to figure out how stuff like hooks together in this environment. Yeah, multiple hours just looking, trying to find that one thing that's gonna like take you further. That's one part of like the data you get access to, but also stuff like, I don't know, Bloodhound, information from AD, information from computers. Yeah, all kinds of information. Some examples, like, yeah, there's information everywhere, right? And we're not kind of taking advantage of it. There's from Bloodhound, port scanning, your C2, whatever, and also your network web app scanning or stuff like that. So. And then now, from the offensive security part, like, okay, we have all this data and stuff like that. How can we kind of take advantage of that? Well, I'm going to try to briefly, like, describe AI. And again, this is really from a practitioner type of view. So if you know this stuff, I'm sorry again, I'm going to botch it. But the point being that you don't really have to be an expert to take or to utilize some of these tools that has kind of appeared the last year or the last periods. So it's important because people are very scared. Like not you guys in general, not you, but people in general are fairly scared of AI. Every time we have like a new thing, like when ChatGPT arrives, suddenly it's gonna destroy the world or something like that. But it's important for us to define that we are still at the infancy stage of what AI can do for us. We have these concepts called ANI, AGI, and ASI, which is basically just artificial narrow intelligence, and then general intelligence, and then super intelligence. And narrow intelligence is basically a toddler or a kid just learning to like write or draw. It has a very narrow range of abilities. In the general intelligence type, well, we have an AI who's kind of on par with us humans or like grown-ups. They have all the capabilities that we have. And then again, we have like the SI, which would be Skynet and iRobot, and I don't know. We're very, very far away from that. We're still here, and there's like a ton of time until we're like over there. But unfortunately, people believe that it's all magic and it's like it's going to take over the world, but we're still here. It's still fairly understandable, even for me. When I took a master's degree in information security, and I was forced to do some AI stuff there, and data mining and stuff like that. And we primarily learned about supervised and unsupervised learning. We're not going to talk about that today, but it's still kind of relevant. Supervised is, well, machine learning in general is, it takes some input, like you give it a data set. You give it some data, usually a ton of it, kind of like the stuff that we already have, like in hint for the talk. But you give it some data, and in the supervised learning, if you use that, you pre-label the training sets, right? So take emails, for example. You have 10,000 good emails that you manually labeled as good, and then you have 10,000 bad emails that you manually label as bad. You train your model on that, and then you give it some random email, and it'll kind of classify it. That's supervising. You're helping it kind of decides on what it should do and not do. That's simplifying it, but yeah. Then you have unsupervised learning, which would be, I'm not going to help you, figure it out on your own. Very common for clustering, trying to find connections between things that we're maybe not able to see as humans. So it's very interesting in kind of social graphs or marketing analysis, and also recommendation engines. Looking at Amazon, for instance, being able to say, like, okay, with this huge corpus of data, if you buy this item, you're probably interested in that item, because there's not an Amazon employee who's like, yeah, if you buy this, you probably want to buy that. So there's no one like sitting manually labeling thousands and thousands and thousands of items. It's unsupervised, largely unsupervised. Then we have deep learning, and that's kind of the part we're going to go into in general in this talk. And then reinforced learning, that's again above my level, but goes more into robotics, more into training and rewarding a system, and then it learns from that. For the deep learning part, there's this new, well, it's not really new, but it's fairly new, like mainstream new, called generative AI. Because traditionally, these machine learning models haven't really produced anything. Like it's more like you ask it a question, or like you ask it to do something and it does that thing. It's not like generating stuff from thin air. But that's what's so cool about generative AI. We've already talked about LLMs. So you probably all know about ChatGPT. Some of you might have used Midjourney or Stable Diffusion for generating cool images, and we saw a talk earlier where I believe the images was produced using some type of generative AI, and also audio. And we're seeing audio being used, or should I say misused already, for faking people's voices, and that's real. Like that's actually something that's happening right now, and it's being used / misused by actors, threat actors. And many more. There's probably a ton more things you can actually like generate, but yeah. Just to go into LLMs, because that's kind of what we're gonna focus most on. I'm gonna simplify this very much, but it's gonna, it's just enough to kind of, isn't like the Dunning-Kruger curve, like you think you know about it, and then yeah. Anyways, so there are a neural network with trillions of weights. A neural network, again, this is a simplification, but it has some input parameters, and then it has tons of hidden layers that are weighted, or that have some impact or redirects, or I don't have a good way to describe it, but kind of the data you put in is transformed via going through all these nodes, and then you get an output node. And it's difficult to know exactly how it arrives at the conclusion it does, because this is built, or this is trained. So you give it a ton of data, it trains itself, and obviously it's not like, what's that, 12 nodes? It's trillions, right? And you train it on a lot of documents, and that's kind of the, if you kind of look at the news today, they talk about plagiarism. So people, it steals the information from the internet, and then it uses that in the model, and that's kind of true, kind of what it does. At least it kind of indexes, or it ingests all of that information, and then it builds these types of vector spaces. And vector spaces is very simplified. Now I'm using words because these models doesn't use words, but they use numbers that represent words, and those words have some sort of vector space that places them close to other words that relate to them. So if I read 1,000 documents about an apple, for instance, well, it could be the Apple computer or the iPhone. It could be an apple, or apple tree, the fruit apple, or it could be an orange. And then it tries to kind of put those in a relation to each other, depending on what's most likely. Now, in modern, like complex LLMs, there are multiple vector spaces. And that's what gives it context. So if you have kind of context, if, for instance, like you ask ChatGPT, I want to know more about the Apple computer. Well, it's going to look and try to find the vector space where it's been trained on Apple and computers more in general than apples and fruit trees, for instance. So it has multiple different types of vector spaces that it can kind of use to create the context or the feeling that it understands what you're talking about. So that's, again, this is very simplified. But it's important because it kind of answers this common misconception that LLMs are just copy-pasting stuff from the internet and like, you know, copying snippets from here and there and like, gluing them together and like brushing it over, making sure it's syntactically correct. But that's not how it works at all. It ingests every word and then it calculates like the chance between each and every word, how likely they are to actually appear together. So it has no, and that's also why ChatGPT is unable to give you like the citation, because it doesn't have that. It's just trained its model to kind of I'm not going to say feel because I'm not going to humanify AI, but it's just a score. Like, what's the most likely word to follow now? All right. So now the whole thing about the talk in general. Let's meet. Let's put offensive security and AI together. And just before I say anything about that, it's important. I wanted to touch on what Andre said. It's so funny because again he had the chance to say it first. But in my experience, we're generally late to the party when new technology arrives. We're very slow at adopting automation, DevOps, AI. SOAR or whatever, like any type of new technology, offensive security is fairly slow, and I believe that's because the stuff we do still works. There's really no need, and one could look at it and say like it's adding complexity or it doesn't really matter. But for us to kind of push the field forward, I think it's important that we take that step back and look at this and like, is there any other way we can look at it? It was a wonderful suggestion going to other developer conferences and seeing what they're talking about, because we kind of live in our own bubble. So we need to break out of that and try to look outside and try to see if there's anything else we can do. I assume that most of you already used ChatGPT. So this is going to be very, very obvious for you. But it's still, if there's someone here who's like, I didn't think that was possible. Well, that's why we have the low-hanging fruits. So just an example then. What can we as offensive operators use ChatGPT for? Well, for instance, we can make it write command line commands for us. This will be very simple. I botched the IP address on purpose. And it's funny because it also tells me that I'm an idiot and that's not a valid IPv4 address. I don't like its attitude, but I made sure to comment that later. But it still gives me like the stuff I wanted. And this is, that's in retrospect, it's a very, very simple command. But say you're writing, I don't know, how many use hashcat and like know every single parameter in hashcat for masks and for word list and for all of that. I don't, but yeah, that might just be me. But then I can use this, obviously, to kind of just kickstart whatever I'm doing. Give me, and it's not always perfect, and we'll get back to that as well. But ChatGPT has read all the documentation. They already have ingested the documentation. I haven't read the man page. Who does that? But yeah, so they have all the information already. Another thing you can do, and you can ask it for tool suggestions. Like, hey, I want to scan a bunch of IP addresses. How do I do that? And obviously, it gives you like you shouldn't make sure that you're doing it. It could be unauthorized and stuff like that. But again, it still kind of gives you the information. You just have to wait for it to type out the first part. In that case, it gives me Nmap and mass_scan, which I guess would be what I would use, but it also suggests Zmap and for some reason Angry IP Scanner for those who are gonna take the certified ethical hacker exam. But another cool thing that I didn't prompt it to do, I didn't ask it to give me that information, but it suggests Showdown and Census as an alternative way to acquire that information. Well, it's obviously not really what I wanted, but it could be a good way, way to learn about something else, or to like reconsider. Maybe I don't need to scan this IP space range. Maybe I can just look it up in Showdown. And obviously, you're not going to get all the ports because Showdown doesn't scan all the ports. But maybe that's not the point. So that's very interesting. Again, I didn't ask it to give me any options. I wanted to scan some IPs, and this is what it gave me. So as a kind of a learning tool as well, I think it's a good idea to use it. Also, I title this "Help Getting an Overview," but also kind of making stuff more systematic or parsing stuff. ChatGPT is very good. So this is, I'm going to give it some IP addresses with some ports. I want it to kind of tell me what are those ports and classify which of those assets are more likely to be vulnerable than another. Is there anyone who's want to take a bet on which of those IPs would be like the worst? No fans of Telnet here. No, that's fine. So again, it's going to give you, and it's fairly pretty as well. Gives you an overview, and it even has like port 1337, often used for elite or hacker services. Sounds cool. It highlights the Telnet part, and I guess the coolest part is, okay, it's going to give you a vulnerability analysis and tell you about all the different types of ports. And again, I didn't really ask for this, but that's what it gave me, and it's a good indicator that, okay, maybe I should look into those services. And to kind of finish off the result it gave me, well, we consider the most vulnerable to be Telnet and FTP. And then potentially vulnerable, and then probably not as vulnerable. And again, this obviously isn't perfect, but it might give you kind of an idea of where to look first, for instance. It can also, help you write reports. Obviously, you got to be careful copy pasting data into ChatGPT. In my professional opinion, if what ChatGPT returns is something that I can stand for, do I have to write all of that process just to say it's mine? I'm not sure. People copy paste anyways from the internet. And again, it's going to give you a ton of information. And what's also cool is that it's going to give you information like, obviously explaining what SQL injection is, which is what I initially wanted. I wanted to have something to copy paste into a report. But it's also saying, oh well, some of the malicious actions you could do could be like reading sensitive data, modifying data, possibly executing commands, which I think you could use as kind of a indicator where you could say, oh, maybe I should go back and revisit that SQL injection that I discovered and make sure to see if I can actually hit those malicious actions and see if those are possible. So it's kind of a way to give yourself kind of a checklist to okay, do more and kind of really prove that the SQL injection you found is good. And obviously, I wouldn't copy paste all of this into a report. That would be too much irrelevant information. But it's nice as kind of a tool for guiding you. It can also create some horrible PowerPoints. I tried just for fun to generate PowerPoint based on this presentation, and it gave me absolutely nothing. So, or it gave me this, but yeah, barely usable. But what's cool about this, it gives you the Python code, or it shows you the Python code that it used to generate the slides. That's an add-on you have to turn on in ChatGPT. But what's so cool then is you could take the PowerPoint code, and in theory, you could create your own report to presentation Python script and just slap on your own theme. And in theory, you could yeah, sure, I can create that presentation, and then you hit a button and you have the presentation. So that's also cool. Automation again. It's very relevant when it comes to reporting, because that's a very, very sad process. So again, kind of back to all of that data we talked about. Now, obviously, all of that data that we receive from Bloodhound or from whatever tool we're running, we can't really paste that into ChatGPT. That wouldn't be good. So what I'm going to show now is outdated, or probably already outdated, because this is a field that's moving very, 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 very fast. It's running ahead. But as an example, you have projects like Private GPT, which you can run on your own machine. It requires some decent GPU power, but in general, you can kind of create your own ChatGPT and then base it on the documents or the data that you have available. And it's built with LangChain, GPT4All, Chroma, and Llama CPP and sentence transformers. These are all building blocks that are, all of those building blocks are always getting better. So again, this might not be the best option for running stuff on your own right now, but again, it's moving so fast. What's so cool about this in particular is because it uses LangChain, it's able to ingest all of these types of files. So everything from plain text TXT files to Evernote, to EPUB, to Markdown, or even something as cool as Outlook messages. Just like Outlook. I was gonna say there's one more, EML. So in theory, you can ingest a wide variety of stuff that you find during a pen test into this. And just to kind of give an idea, you're probably all familiar with MITRE ATT&CK, which is a library of tactics, techniques, and common knowledge for what you do during each stage of your, offensive operation. It contains 1,000 different sub-techniques that all generate more data, which is would be interesting to look at. And this is my attempt at putting all of MITRE into one slide, which always fails. But make sure you can read that, because there's a Kahoot afterwards. So. One tool that generates data would be FOCA, or FOCA, fingerprinting organizations with collected archives. Often used in the reconnaissance phase. If you're it uses Google, Bing, DuckDuckGo for searching for files related to the company you're looking up. So, say you're looking at Covert, it would try to find PDFs or any type of file that contains the word Covert or are related to Covert. And that's something you could ingest easily. File shares, we already talked about file shares. ManSpider is a tool which doesn't necessarily fit into this category, or like the private GPT part as well. But what it does is it looks through, it uses regular expression, and it searches through all the files in a file share. But what you could do instead is just take all the files from the file share and ingest them into private GPT, and then you can have it searchable there instead. It wouldn't be as straightforward as this. You can't just run regular expression inside of a LLM. That's not how it works, unfortunately, and we'll get kind of back to that. But that might be one way to do that type of ingestion. Another very cool tool is from a guy named Flangevik. He created a tool where if you're able to compromise a Microsoft account, online account, it's able to exfiltrate data like emails, Skype, nah, not Skype, sorry, team messages, calendar, and stuff like that. And that's, again, is something you could ingest. Like, you could ingest the chat, you could ingest all the emails, and then you can start prompting into that. So, is it as easy as just ingesting it? Well, you have to remember that it's not like the LLM knows what you're doing. It's not like it knows that the stuff I'm ingesting now is it doesn't know what you're going to do with it. So when you prompt it, you can't just say, give me a password that you found in some documentation, because it doesn't know what the password is, probably. It's not kind of capable of that. But you can probably, and this is again depending on kind of the development of these free or available LLMs, start asking it like, where's your backup server located? Where's your, what's the, like, you can ask it more configuration types of questions. And that was also mentioned in a talk earlier about, you know, taking documentations and putting them into kind of LLMs type of systems. And I believe that's something that's very in its infancy, but it's going to be more and more relevant. Think about ingesting someone's Confluence, for instance, into a LLM and being able to actually read it and not just waiting for the thing to load. And then, again, prompt into it. Just want to mention common pitfalls. There are some things you need to remember when working with these types of tools or projects. First of all, obviously, the stuff you put into it is also basically the stuff you get out of it. So if you have any type of bias in your data set, that's obviously going to reflect in the result you're getting. So some say, you know, shit in, shit out, and that's kind of goes for this as well. And that's, I guess that's AI in general. Also misinformation. Again, back to the stuff that you're ingesting, and this is also a thing that people are discussing regarding LLMs. Is it just ingests stuff from all over the internet, right? So if you're able to, like, if it suddenly parses some flat earther website or something, it could in theory be make it believe, or like you can end up prompting and saying that, you know, the world is flat. So and it has no, you know, it has no context. It doesn't know that that's necessarily wrong or right, only depending on the weight. So if someone publishes a ton of flat Earth theories, well, in theory, ChatGPT is going to start saying that the world is flat, because it's just calculations, right? What's most likely. Another very important part is hallucination, and this is something that people really haven't been able to wrap their head around when trying to prompt stuff, especially in ChatGPT. The model will try its very, 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 very best to give you what it thinks you want. So if you ask ChatGPT what is Martin's phone number, it's going to give you a number. It's not going to be mine. I'm fairly sure. Yeah, I'm fairly sure. But it's still like it's like, this is the most likely thing I could come up with, and that's what you get. And that goes for kind of all of it. So you have to take everything it kind of gives you with a large grain of salt. Yeah, it can hallucinate, and that's a problem. And that's kind of the pitfall with people who don't understand that when they use ChatGPT. It's like asking ChatGPT to figure out if a text has been written with ChatGPT. It's very, very bingo. And also back to kind of the ownership of generated content, we can kind of avoid that in general by ingesting stuff that we, you know, privately ingest stuff that we only use for that engagement. But I mean, it would be interesting to take all the reports you've ever written, all the information you ever gathered, and like smash them into one model and see kind of what it gives you. Is it ethical? I'm not a lawyer, so I don't know. But also, again, the generated content, the thing is, again, back to it's not copy pasting stuff. It doesn't have a database of like this came from there and that's it doesn't have it's nothing like that. So it's something that needs to be considered and hopefully avoided by going offline instead of using, for instance, ChatGPT for stuff that it shouldn't have access to. I'm getting thirsty, so thank you for your time. Yeah, we do some cyber stuff if you want to contact us, but yeah, thank you so much.
Thanks, Martin. We do a couple questions. Does anybody have questions? Yeah.
Uh-oh.
He's thirsty. Watch out.
Have you used this on engagements with customers?
In general, yes.
What are your experiences regarding, as you said, the models tend to stick to the information that they know from before. What's your experience with how often the model hallucinates? What are your experiences with trying to ingest all of this random data into a model that has not been, to some extent, it's probably not been trained extensively on the new information?
Yeah.
How?
It's not. It's still in its infancy. That's it's not where I want it to be, and it's easy to kind of dream up scenarios where you can like ask it to do whatever you want, like give me all the information about every Windows host or whatever. It's not there yet. That could be fixable with restructuring the data before ingesting it, better language models. It's still a work in progress. What it's decent at is taking emails and kind of not necessarily parsing them, but parsing them, but not necessarily recalling them, because again, it's not able to recall anything. But typing something in the word of something else, and this goes back to kind of the context and the vector spaces. But it is able to kind of say, if I wanted you to write this in the voice of the CEO, it's ish able to do that. But again, it's not perfect. We tested it. It's not our daily driver, but yeah.
Anybody else have questions for Martin Ingesen about possible uses of AI in offensive security operations? Yes, coming your way. Keep your hand up. Thank you.
Have you seen any changes in restrictions regarding what information it will give you, considering that they're kind of cutting down on what information you can get?
The information I get from the model, you think?
Yeah, in terms of offensive security, that it won't allow.
Yeah. So the nice thing about running stuff on your own is that you don't have the guardrails. So like for ChatGPT, as you already saw, it kind of tells you like you need to don't use this for malicious purposes, and that's a part of the ChatGPT model that it's not necessarily trained on that, but it has guardrails kind of around it, if that makes sense, to kind of protect the model from doing stuff that OpenAI doesn't want it to do. If you run it on your own, you don't have those guardrails. So that's kind of. But my experience has been that it's been more relaxed. It's not as restrictive, and it's not shouting at you as soon as it kind of feels like you're trying to hack. So ChatGPT as well kind of feels more like, yeah, it gives you warning, but it still gives you basically the result you're after. So it seems like they kind of tuned that a bit down, but that could be anecdotal.
Okay, so for GPT, exploit code and stuff like that, there hasn't been any stronger restrictions going forward than what it was, say, a few months ago, that you have seen?
Yeah, so from my experience, no. Like if anything, it's become more relaxed. And also the thing is, kind of bypasses for those type of guardrails that are so common now. You know, it's like my grandmother used to write exploit code, and I would love to like learn something from blah blah blah, and then it kind of for some reason kind of bypasses those guardrails, and suddenly it gives you exploit code. What's worth mentioning is that the code it gives you is usually like crap at best, and you have to like tune it and help it to tune it. But in general, it doesn't. The guardrails are generally bypassable. Thank you.
Any other questions for Martin? I have a question. You said it wouldn't be a good idea to paste client IP addresses into ChatGPT. What about pasting client IP addresses into the enterprise ChatGPT?
Well, again, I'm not a lawyer.
No, but to qualify a little bit, when we in the VIPS talk from Nora and Kenneth, they talked about app-attest, right? So if we use app-attest, then Google tells us we can trust this app, but then we still have to trust Google, right? So how much do we trust Google? How much do we trust ChatGPT? And it's not is it legal, but
yeah,
how much do we trust?
That's a good point. And a thing that I want to add is I mentioned that we're all often very late to the party. Like chatbots that builds on LLMs are already being built into Office, for instance. It's already reading your email. At least it has the capability to do that, and it's a toggle away. And at some point in some organization, that's going to happen. So at some point you have to trust someone, I guess. We like at Covert, we try to avoid that by self-hosting as much as we can, but yeah, it's again, someone has to have your email anyway. If it's Microsoft, like, why not give Microsoft and again, it has Defender and Defender for Endpoint. It already knows your IP addresses, so by giving it doesn't give you anything else in general.
Thanks, Martin. Anybody else? We good? Thank you very much.
Thank you. Is it beer now?
It's almost beer. It's so close to beer, if that's your jam. Yeah, there are other things available as well. T-shirts, water. Right now, I would like to invite Mike Bates from SANS up on stage. Please give a hand for SANS and providing the CTF for us today.
Thank you, thank you. I hope you all enjoyed the CTF today. Plenty of players, looked very good. Some of you might know me already. I was in a popular band, 1,024 megabytes. We only had the one gig. But then I joined the dark web then, and I was always on tour. But yeah, very popular, very good scores today. But there was only one winner. The top four constantly changed. But the winner today of this prestigious, luxurious, very expensive trophy is Bob the Thief. You there, Bob? We're also doing our SANS training in April at the Radisson Blue Waterfront. There'll be 6 courses, and there'll be a discount code for anyone who's attended today, BSides 2023 or something like that it'll be. So hope to see some of you there. Wherever you want to come, Bob. Congratulations. There you go. Thank you.
Thanks again, Mike. All right. Just a couple last things, and then we will chill downstairs until 6 and come back up here for dinner. I want to thank all of our sponsors again, especially the gold sponsors, Mnemonic, Spotify, and Remarkable and Defendable, for not just funding this so that we can charge a ticket price far below the cost per person to hold this event, but also for participating. We don't look at this event as attendees staff, sponsors. We're all participants here, and everybody that came here today and gave us feedback from the previous events made this event what it was. So thank you to all of our participants, our speakers, our volunteers, and all of you as well. And to continue to hold this event in the future and have it grow in a way that serves this community, we would very much appreciate that all of you who registered with your email address will respond to the feedback survey that will go out in the next 24 hours. It shouldn't take more than 5 minutes, and that feedback will help us to determine how to serve the community in the future. We could make this event bigger, potentially. We could have more tracks, more days, but the feedback that we received is that folks liked the venue and found the one-day, one-track event kind of accessible and intimate. Nobody used that word. But it's a shared experience, right? We're not hopping between tracks, and you come with your colleagues and then everybody sort of goes their separate ways, and that's great too, because you can get really honed in on your area and see all the talks on just your thing. But this is sort of the opposite, where there's a little something for everybody, but there's also, you're going to be exposed to new things that you might not pick if you had 15 other tracks to choose from. So these are the kind of things we're wondering. Do we just do this again, or what should we do? And what did you like? What did you didn't like? So please respond to the survey, and if you have comments, good and bad, put those in the text field as well. If there are any, here's this last thing I'm going to say about T-shirts. If you want one, there's probably one kicking around somewhere downstairs, and grab some fortune cookies, stick them in your bag, bring them to the office. They do have cyber security jokes inside. They're not ordinary astrology-based fortune cookies. I think that's it. I want to invite the volunteers up on stage now to thank them myself, and so that you can see the entire group basically that puts on this event. We're a nonprofit, and 100% volunteer work that goes into the event. Do we have folks? Anybody coming up? Anybody want to say anything? No. This is the team, the BSides team, and our media volunteer from Elvebakken. Is there anybody else still from Elvebakken that wants to come up? You want to come up on stage? No? Well, thanks for sitting in almost the back row and giving us a wave. All right. Thanks, everybody. Yeah, it looks like we are lacking a bartender downstairs, so we'll sort that now. That's top priority. Hello.